Apparently I can start. Hopefully you can see my video. Can someone confirm for me that that's true? Looking good. Awesome. Thank you, everybody. Hi. Welcome. Welcome to the IPFS Implementations Workshop. It's May 20th, 2022 in most places on the planet. And my name's B5, and I'm going to be your master of ceremonies for this pretty informal, but hopefully super delightful workshop presentation. I prepared a few sort of opening remarks just to get us kicked off, and I'm going to set a timer to make sure that I don't go totally crazy with my time. And hopefully we can sort of get started. Ideally, today will be a super fun conversation about IPFS implementations. And with that, I'm going to see if I can go full screen here just to keep things super exciting. All right. Hopefully everybody can see the title slide. Welcome to the IPFS Implementations Workshop. As I mentioned, I'm B5 on the internet. I've been a member of the IPFS community for a number of years, and really excited to talk with all of you about IPFS today. So when we're talking about implementations, I've been noodling on this a little bit before we had the workshop, and I think there's been a fun framework to sort of use as a method of approaching the question of what an implementation is. And I think we can kind of break it down along three characteristics that are always present when we're talking about an implementation. We can think about languages, platforms, and use cases. And some of these terms are a little bit sort of vague and kind of on purpose. I think languages is pretty clear. We're talking about the classic programming languages, Go, JavaScript, Haskell, you name it. We talk about platforms. That's where we can get a little more blurry. We can think of a browser as a platform. You can think about the command line as a platform. But you can also sort of drop that down a level and think about a specific browser engine as a platform. We could think about WebKit or Gecko or Servo, whatever browser platform you can think of. That too could be thought of as a platform. And then we get to use cases. This is sort of the space between applications and intended uses for a protocol. And I think that's intentionally large and intentionally sort of vague. We want to allow people to explore that space in a lot of ways. But I think this framework is really useful for thinking about an implementation because it gives a sufficiently broad definition to fit a lot of different things when we say the word implementation. We can start with a classic example, JS IPFS. If we just look at the top line sort of description of JS IPFS from their website, you have a language, a number of platforms, and a suggestion of a number of use cases. The same thing can apply to a more discrete project like Capyloon. Capyloon is an experimental user agent. To me, that's a platform that aims to give you what you deserve, privacy and control and freedom from constraints. In my mind, that's a use case. And I happen to know that Capyloon is written in Rust, which is obviously a language. But I think that's a really useful framework for understanding how we think about the sort of day-to-day operations of an implementation. And we will be talking about that a bunch today. But in addition to the sort of step-by-step implementations conversation, we have a broader sort of macro level conversation. And for that, I think that's why events like this are really exciting. It's a chance to sort of step back and say, hey, what are we really doing here? And I'm going to take a risk and try and do comedy in a room with no sort of reactionary space on the internet. And we'll see how this goes. But to sort of set the tone for today, I want to tell you a story. And this is a true story. And it starts in 1983 on the MIT campus. In 1983, a bunch of folks from MIT received a $50 million grant. That is a large grant. That is $145 million if you live in 2022. It's a lot of money. That grant came from two organizations, the Digital Equipment Company, or DEC, and IBM. And this grant was in the form of both hardware and actual funds. And it was for a project called Project Athena. And the goal of Project Athena was to bring computers to disciplines beyond computer science, which sounds a little bit sort of wild to our today ears. But like at this point, computers are really only used in the computer science department at MIT. Nobody else had really sort of played with them. So if you were a social science student, you didn't use a computer. And this project was a massive undertaking to try and change that. The thing that they ended up making were rooms that looked like this. In kind of, Project Athena can kind of lay claim to inventing the computer lab. And along the way, there were a number of challenges to inventing the computer lab. Specifically, you have these two donation sources. You have IBM and Digital DEC both contributing pieces to this platform. But MIT, as a as a faculty in an educational institution, wanted a uniform experience for the students. They didn't want everybody to have to learn, the IBM platform and the DEC platform at the same time. And so there's a real, like, how do we pull this off? And like the total bosses that they are, in 1983, they say, okay, let's go Unix, let's build a distributed system. This is going to be great. It still boggles my mind that 1983 people were like, yeah, let's go distributed. And we're still having these conversations today. But they tried it, and they invented what we now know today as the thin client model, where, yes, our modern interpretation of that phrasing is not so great, but at the time, it's really interesting as a method of abstracting over DEC machines and IBM machines. So the general framework they were aiming for here was any student can go up to any terminal, be it IBM or DEC, and access their own files and be able to sort of have a uniform experience. But there's one problem with that approach at the time. How do you deal with the display, right? You want to use the display and the input from the keyboard, and you want to be sending that over a network connection to a remote access machine. But like actually driving the display was a thing that hadn't really been conquered yet. There are other implementations, but nothing that was available to MIT that they could license. And so, like all good things, there's a message just sent on a message board. And I'm actually going to break the rule of speakers and just read this to you out loud. Because this happened in 1983, and I think it's just this lovely piece of history. I spent the last couple of weeks writing a Windows system for the VS100. I stole a fair amount of code from W, which is a prior Windows system, surrounded it with an asynchronous rather than synchronous code, and called it X. Overall performance seems to be about twice that of W. The code seems fairly solid at this point, although there are still some deficiencies we fix up. We're using X. Everybody should switch. This is going to be awesome. It's not the ultimate Windows system, but I believe it's a good starting point. And at this point, there's an interface. And wait a second, hold on. If we can apply our framework, we can see there's a mention of languages, platforms, and use cases. There are applications that people are trying to use, and people are still begging for documentation. The bottom paragraph does kind of date this thing. Anyone interested in seeing a demo should come by this room, should call me on this thing first. And anybody who wants the code can come by with a tape, which I think is just lovely. I want to go visit people with a tape to get source code. I think today's a little different. But aside from that, this kind of looks like a conversation that happens today. And I think in a lot of ways, this is setting the groundwork of culture as we experience it nowadays. But what came out of that ended up being called the X window system. Logo came later, and yes, that's Emacs. And this was the mechanism for writing a platform-neutral abstraction for doing displays over DEC and IBM machines. And this project goes well. It is really popular really early. At this point, everybody starts using it inside of MIT, and demand for it grows beyond the bounds of MIT. People inside of labs are using it, and the software itself is gaining popularity, and to the point that in 1985, people get excited. A number of implementations get written. We get one for the IBM RT PC, the DEC workstations, HP workstations, Apollo workstations, Sun workstations. The IBM personal computer gets an implementation. And all of this is because of a thing that was brand new to this project, which we now understand is the MIT license. And yeah, this project is actually kind of one of the precursors to open source. And I think, if we take a very objective look at what that looked like at the time, it was a really exciting time for the X Window project. They had funding and a use case, they got some code to work, they got a number of implementations, and they reached a degree of incumbency. And in 1985, it's like a really exciting position to be in for any technology. And so maybe that's the lesson, right? Open source is great, more implementations, better, at the end. We should just stop there. Why even bother with the workshop? And I think this is the point that I'm trying to make with this story. This story is halfway finished. Where this goes from here is a really exciting sort of series of harrowing decisions that are of increasing risk based on really smart guidance from a number of folks working on the X Window project. In 1986, the DEC Western Digital Laboratory steps in. These folks are basically the A team of software at the time, or they were A team, depending on how you think about it. But they were really fantastic. They jump in chat and say like, hey, we want to rewrite X because we want to take it from version 10 to 11. We think we can make it a little more neutral. Sounds great. People from MIT are like, all right, sure, but you got to keep the license the way it is. And we're going to do this out in the open. And surprisingly, this phenomenal software team is like, yeah, why don't we just do this in a way where we can just have conversations out in the open about the design of the API? And MIT says, yeah, sure, let's do it. Flame emojis. X version 11 comes out, and as much as things were great before, at this point, things really start to take off. It goes to the next level in every sense of the word. More than 9 hardware vendors start building on top of this system. The X window system achieves a degree of popularity where it is not just the incumbent thing, it is the thing to build commercial products on top of. It is still licensed under the MIT license. MIT is still the steward of this project. It's so scary to MIT at this point that they actually have like what I think we now look back on as a moment of weakness. And they say, hey, we want to go give this license to a vendor because this is just too hot to handle for us. And in one of the most incredible turns of governance I can think of, all of the vendors come back and say, no, actually, this is better if a neutral party controls the actual project, which I think is just like an amazing moment in the history of open source. After that, more than 1,200, at one point, more than 1,200 employees are working on DEC, on X implementations at DEC. 1,200 people grinding on the X window system. Like, imagine that from back in the day. At this point, it's 2022. The X window system still exists. I checked the releases page on May 5th. Where is it? No, May 3rd. There was an update to the lib. This project is still going. And I think that's just like an incredible story of like, at this point, it's reached the level of where it is like just assumed infrastructure inside of computing. And I think that's what's exciting here. You know, in 1985, these folks are thinking, wow, incumbency, that's incredible. And what actually ended up happening is this litness scale goes from linear to log. And we have just an incredible series of events that happen that take the X window project into a whole new stratosphere. And in a lot of ways, is the first real large-scale open source project. The way in which that's precedent setting is incredible. And I think that's what I want to remind us of as we go into today's workshop, is if we overlay this sort of as a template onto our ecosystem and think about IPFS, I think we're here. I think we're at a point where, you know, IPFS had funding, we had a working implementation, we have multiple implementations. It's fair to say that IPFS is the method of addressing off-chain data in Web3. And the future is unwritten. And I think for a lot of folks who you'll be hearing speaking today and a lot of folks in the ecosystem, we don't really need to be told what it felt like to be sort of like the first people in open source, because it's that scary feeling that we have today when we think about advancing such an incredibly important project like IPFS. And what I'm here to tell you is we're gathered today to sort of try and understand where this could go. And this could go in a totally exciting and big way. The best days of IPFS in so many ways could be ahead of us. And I think that's what's exciting. There's really, you know, we do have 2 frameworks that I think I'd like us to keep in mind as we look at today's talks. We have both the micro, which sounds kind of like, I don't know, like it makes micro sound like it's less than the macro. I don't believe that at all. I think the micro is just the way that we walk our way through history. There's also the macro scale of things. And this like sustainability, collaboration, and governance, I think is a little underdeveloped. I'd love to sort of move that conversation forward as we work today. But for projects like this to work and for them to achieve the sort of great heights like the X window system did, it takes a lot of bold action and coordinated behavior on the part of folks like us. And so with today's workshop, I'm really hoping that we can get into the weeds a little bit on this conversation. I hope that we can stay centered and think big and remember that we're all here to really advance incredible and exciting technology. So that we have a pretty solid schedule lined up for you today. All the hitters are here. Okay, a lot of the hitters are here. I would actually love even more folks to be joined in this workshop, but these are the folks that could join today. And we're gonna go right into it. I think from here, we'll take a quick pause and we'll switch over to Mauve. They have a wonderful presentation prepared for us. Mauve has been around and has seen more than a few peer-to-peer protocols and has some wonderful things to tell us about Agricore. And so with that, we'll take a quick pause and switch over to Mauve. Thank you so much, and thank you for joining. Okay, Mauve, I think you can take it away. Let me, oh, no, hold on. Give me 1 second. How do I do this? Chat participants. I apologize, everyone. You're all going to hear me talking myself through setting up a presentation. This one. Okay. Mauve, I can see you. I can see your browser. Take it away.
Sweet. Hello. Thanks. And thanks for everyone for coming out, or I guess watching this recording after the fact. So I'm going to be talking about mixing different peer-to-peer protocols with the web with Agricore. So I'm Mauve. My pronouns are they, them. Everywhere on the internet, I'm at Ranger Mauve. And I do consulting for decentralized software with Mauve Software Inc., which is pretty much just me. And I'm kind of obsessed with peer-to-peer protocols. I really like them because they enable me to stop hoarding user data as a developer. So my applications can like stop worrying about managing backend infrastructure and privacy and all of that. And instead, all interactions between users are done directly rather than being mediated through a third party. So one of the cool parts of this is there's no longer a central point of failure to go offline either. And so if you're within network range of somebody, you can still use all your peer-to-peer apps without a hitch. So since this is an IPFS meetup, we're mostly going to be focusing on IPFS in Agricore, but it supports a whole bunch of different protocols, which I'll kind of like slightly touch on later. Oh, my clipping is totally off, but that's fine. So IPFS is great because it's an example of a really versatile protocol, which can store a bunch of different data types. And this is thanks to it having a layered model with content addressing and mutability. So one of the cool things is since content is addressed by individual chunks and you discover content individually, that means that you can maximally reuse data across large data sets. So say you have, reusable libraries or reusable images, your clients can automatically reshare that data and avoid re-downloading it when you don't need to. This, of course, does take a little bit of a performance hit in that your IPFS node now needs to do a lot more traffic. So as well, another thing IPFS lets us do is in order just outside of loading data arbitrarily that's content addressable, we can also load mutable data through IPNS, which is also super useful because oftentimes if people are working with data, they want to update it. And so you can actually see this protocol being used in the wild right now in places where they do stuff like web archiving with Web Recorder, or a lot of Web3/blockchain things use it as a reliable storage mechanism that's off-chain. So on its own, it's pretty useful, but what would it look like to integrate IPFS deeply with the web? So the first part that you kind of see when you interact with some data is URLs. And most protocols in Agricore and really out there have some sort of URL scheme for identifying data. And URLs consist of the scheme parts, which identifies what kind of data is, usually an origin of sorts, which kind of represents a data or can be used by web browsers to section off storage for different domains, a path, which might give you more specific data, and the search params, which can give you like extra kind of like querying and metadata about the information you want. So you can see some examples of peer-to-peer URLs that follow this scheme. So with IPFS, we have CIDV1 hashes or identifiers for content. BitTorrent has info hashes, which are pretty similar. Hypercore protocol has public keys, And with IPNS, you can use good old DNS if you want to set that up. So these URLs are used all over the place on the web for loading web pages with HTML or embedding them with iframes, for loading different images, for audio, video, styling web pages, and also scripting and making things interactive. So if I'm loading any sort of code on the web, I'm probably talking to a URL. And you can talk to these URLs from code using the browser's fetch API, which lets you do HTTP requests normally, or through other APIs like event source, which let you listen in on incoming data from a URL. So one step further past URLs is HTTP or RESTful interfaces, which is kind of the thing that's been a little bit more new in the IPFS space that I've been exploring with Agricore. Right now, most of the gateways that people work with are really used to get data out. But HTTP actually has a bunch of extra methods that we can use. So with HTTP, you can use different methods like get, which is the default, to download data, post, which is to upload new data, put, which is pretty much the same thing, delete, and other such verbs. You operate on URLs and you tell usually a web server, or in this case, your user agent, what you want to do with a URL. And you might add some extra metadata for headers. And optionally, also, if you're uploading content, you might give it a request body. The server, or in this case, the user agent or protocol, will then tell you a status of whether it succeeded or flopped, maybe some other headers for extra metadata. And if you're downloading data or downloading some sort of information, it will give you the body. So most commonly, we see this when we want to get some data, say from HTTP, but the same thing could be said about using get for IPNS, where we might want to download data from IPNS as a protocol. And similarly, we might think about uploading data to a peer-to-peer protocol like Hypercore, where we'll post hello worlds to a text file and then expect others to be able to then get that back out of the peer-to-peer protocol. So this is kind of how web development already works. And this is just one more step that I've taken to kind of bring web development to the peer-to-peer space and kind of mix those two together. So right now, there's been a few web browsers that have kind of tried doing peer-to-peer, but the latest effort, I think, and the effort I'm focused on is the Agricore Browser, which is a really minimal web browser, which didn't want to think like any like super fancy functionality other than just experimenting with mixing different peer-to-peer protocols with HTTP-like interfaces. And instead of making assumptions and adding features, it uses web extensions, which also have access to these peer-to-peer protocols to customize the browser. So say if you want to have bookmarks, you can just have a bookmarks extension that can publish to IPFS or BitTorrent or whatever else. So right now, we actually support a whole bunch of protocols. Every time I do these talks, we get more and more protocols, which is very exciting. So we have IPFS and IPNS. And more secretly, there's IPLD and PubSub, which, blog post coming. Hypercore protocol, which some folks may have heard of, which is, another peer-to-peer protocol. BitTorrent, which honestly, I think is super underrated. BitTorrent ran so IPFS could walk, or the other way around, I don't remember. But there's a lot of stuff in there. Gun, which is kind of like a graph-based peer-to-peer thing. Gemini, which isn't even peer-to-peer, but is kind of hip, and we love that. And Secure Scuttlebutt, which is also an oldie. So all of these protocols have their own trade-offs and their own things that they're good at or not as good at. And what's cool is that having a similar interface that uses URLs and HTTP-like methods means that developers can more easily approach using them rather than having to figure out how to install every single ecosystem and the different APIs and approaches to working with the data. Now you can think of it in the same way as you would with any web server or with any web content. So that said, what does this actually look like? I'm going to do a live demo because, gotta tempt the demo gods. Can everyone read this? I'm not seeing any problems yet. Cool, I'm going to go for it. I'm actually going to cheat, and I actually already have some code that I pasted earlier, but let's go over and see what it does. So we're going to be using let me actually increase that. We're going to be using the browser's fetch interface in order to upload some data to a peer-to-peer protocol handler. So we're telling the browser we want to talk to IPFS, and we're going to put some data onto IPFS. So there is an existing CID here, which might look kind of funky, which is like an identity CID. But basically, this represents a block of UnixFS v1 or v2 or whatever of an empty directory. And so rather than having a CID that points to a block, which you download that contains the directory, this just does it entirely inline. So we don't even need to touch the network. So it's just like a nice improvement. But what we're saying is take this empty directory and I want to add a file to it called index.md. So spoiler warning, Agricore supports Markdown natively for rendering, because HTML, CSS, that's nice, but sometimes I just want to do stuff. So here in my body, I just place whatever Markdown. It can be like, hi there, IPFS. Ooh. Folks, what's cooking? I can put in a marquee tag because it's still technically HTML related. I submit, I wait a second, and bam. So what this did was it took that body and it fed it to the local IPFS daemon that Agricore comes built with. And it gave that content. The daemon gave back the new CID for the directory that contains the markdown file and the file path. And then the browser included it in the HTTP response and gave it to me here. So now if I copy this link and enter it in my browser, bam, here we go. I just live coded a website. I think I messed up my marquee tag though. Oh, nope, there it is. So I'm gonna tempt fate and post the URL in the Zoom chat for anyone that wants to try that out. It might not work, and that's because this is all super fresh. So there we go, it works, but there's still work to be done. So as part of the work that I've been doing with different peer-to-peer protocols, mentioned before how they have different trade-offs. And IPFS, although I absolutely love it and it does so much, it does have some things that are kind of like screaming to be improved upon. So one of the main things is mutability in IPNS. So if I want to publish to IPNS, at the moment, it's actually super slow. When we were testing it, we were getting like 1 minute and 30 seconds just to upload a CID. And we were working with some folks to speed that up. And even then, right now, after a bunch of improvements, we got it down to like just under 60 seconds. But there's stuff that could be improved there. Similarly, with mutable data, there is a lot to be desired with actually pinning it. Because right now, if you're updating a data set, you either need to use IPNS with a public key or DNS. And when you use the public key, there's a limitation where you can't just tell a service like, hey, keep this online for me forever without either giving them your private key for that IPNS record or periodically publishing yourself with a node that has a private key. So there's also some active conversation with this, and I think we were talking about this in the IPFS Discord recently, or Matrix channel. So there's a pain point, but it can be addressable. And the last thing is hole punching, where actually connecting between computers, even though it is fairly good, it's only been recently that we got this new hole punching functionality that makes it more reliable to connect between two home networks. And so once this is enabled by default and stable, connectivity is going to be a lot better, because at the end of the day, from working with users, the important thing is, can we upload data? Can our friends just download the link without any third things? And can we keep stuff online and mutable? So we're getting really close, and it's very exciting. But why also does any of this stuff matter? Like, why do we actually care about addressing these things? So to me, the peer-to-peer web is something that is very useful for this concept called local first software. And so that's software that works, that's user owned, where rather than a third party owning all of a user's data, a user controls it to start. It's software that can work offline with that user's data, so that if I want to update, some markdown on my blog, I don't need to be online and connected to a service all the time. Similarly, it's software that can work on a local area network. So say we don't have access to the internet, but we're on the same Wi-Fi access point. We should be able to still exchange data because we're right there. We should use our networks. And lastly, it's local first, but it's not local only, in that it can work over the internet if you have that network connection. So this really fits well with peer-to-peer and the web, in that we can have these peer-to-peer protocols for storing and exchanging data. We can exchange entire websites using the same protocols, and everything works like offline and local network and internet network by default. So it makes it easier to write local first software rather than in the cloud use case where you have to like hack around a whole bunch to get that same experience. Similarly, one of the things that I'm really excited about is how this will interplay with community mesh networks, where these are situations where they're often prone to either brownouts or internet outages or blackouts, where you want software that's reliable and that works locally. Also, it's places where internet might be expensive still or slow, where you want to download stuff, but then you want to reuse your local network as much as possible. And similarly, building apps is a huge pain in the ass, especially if you want to go cross-platform. So with Agricore, we support Androids and Linux and Mac and Windows, and hopefully more things eventually, so that now as a developer, you don't have to care about building an app for every platform. You can just, again, focus on a web app, use that peer-to-peer, and you just get all of those niceties for free. So that's kind of Agricore. That's the idea of all these URLs and the protocols. That's what I've been working on. I'm very excited to be working with IPFS folks to push this forward. And it's overall a really exciting match. Yeah, so thanks. Any questions, comments, concerns? Feel free to post in the chat.
Yeah, hopefully others feel free to post in chat. I get the power to just ask you a question audibly, Mo. I'd be very interested. You have been spending a bunch of time spanning across different peer-to-peer protocols. How has the performance characteristics of managing multiple peer-to-peer networks gone? And have you had any challenges there?
Yeah, so one of my philosophies with mixing these peer-to-peer protocols is that if you're not using it, it shouldn't impact performance. So wherever possible, the actual code that executes all of the peer-to-peer stuff isn't even loaded until you use that protocol for the first time. So, and different protocols have different levels of resource usage just by default. So for example, if I'm using Gemini, Gemini doesn't do any peer-to-peer in Agricore. So it's basically like as cheap as HTTP. There's no active daemon running. Kind of in the middle ground is BitTorrent support, where if I'm loading a torrent, it's going to be actively seeding things. And if I have a whole bunch of torrents, it really adds up because they basically have an individual swarm per torrent, if I understand correctly, which isn't ideal. IPFS seems to be the most hungry at the moment. Seems like there's a lot of potential for turning more things off or like reducing usage, where once I access IPFS in Agricore, suddenly it starts, my CPU can start like cranking up a bit more and you feel it a lot more. But it's kind of been different. So for example, in the chat, Adine just posted a link to the Agricore IPFS daemon, which is being used in Agricore Mobile. So in there, we don't have the fancy lazy loading of protocols thing yet, but I found that it's actually not that bad. Everyone is talking about how running IPFS on mobile is going to be like awful for performance and the battery is going to die, but we haven't seen that. And so I think part of that is that we only really keep it active as so far as you're using IPFS. So once you close the app, it's no longer using things, which you lose reliability, but the battery life isn't too bad. So all that to say, it's complicated. Different protocols have different metrics, but it's not too bad, depending on how heavy you use it as well. I see another question in the chat. What happens if no IPFS nodes serves the data? Does it mean data is lost? How do we ensure no data loss in IPFS network? So that's a really big thing. And I think there's like a whole bunch of ways to approach it. I think probably since we're at the IPFS meetup, the most obvious answer is, oh, use Filecoin, where, you know, throw money at it and then it'll be automatically replicated across the network, which is great if you have money and you have internet. Lately, the folks I've been working with, we were looking more at community-based backups of data. So say you have a community of folks you're working with, you might have some tech people that set up an IPFS cluster instance so that as a community, people can send things that they want backed up, which also IPLD or IPNS is a big question there. Another thing is, you know, if you have some folks, maybe you can start a sort of web ring thing where you start backing data up for each other. And so these are patterns that come from a whole bunch of other peer-to-peer networks as well. And so there's a lot of different approaches. The main thing is if you want it to be backed up, pin it on your machine at the very least, because that's the most reliable thing. If it's available locally, it'll be available. If you can't, it gets a lot more complicated. Any other questions?
Anyone have another question, either on stream or on chat? That's great. Thanks so much, Mo. Thank you very much.
Thank you very much. Thanks for having me. Good luck.
Amazing. Thank you. I don't know who you can see or what you can see, but we have a Carson Farmer ready up next. Carson, I think it's cool to just go straight into the next one. Does that sound good, Carson? Can you hear me?
Sure, yeah. Can everybody hear me?
We can, and I'm amazed. Carson has been around for some time and comes from hails to us from Tableland. And Carson, I believe you are calling from a remote location. Is that true?
Yeah, that's true. I think I'm presenting a local first presentation here. I'll give some context on that in a sec. But I am sitting in the back of a Jeep in the middle of the British Columbia forests. And there are tiny children pretending to be dinosaurs running around me right now. So we'll see how this goes. Here we go. So I'm going to share my screen. Does everybody see what I hope they see, which is a slide that says, take what you need, the case for protocols as libraries?
Yes, we do.
Yes, excellent, okay. Yes, so I'm out in the middle of the BC forests, and last night I was literally sitting around a campfire with my laptop, putting this presentation together, kind of reflecting a little bit on Textile and my own journey as part of the interplanetary ecosystem, which is a term I just invented, but will refer to throughout this talk, I think. And then eventually it got pretty dark, but the glow of the screen and the slowly burning embers helped me to reflect a little bit on how we got here and some of the things that enabled Textile and Tableland to build the tools and protocols that we did. So this is actually a talk I've wanted to give for a long time. And then of course I do the thing that I always do, which is leave it to the last minute and write it while I'm sitting around a campfire. But anyway, let's see if how this goes. And I'll take it from there. So me and my team, Textile, some of you may remember us from such products as ThreadDB or Buckets, or maybe more recently Tableland or the Textile Hub. Or maybe if you've been around the IP ecosystem as long as we have, you might remember a product we built called Textile Photos, which was one of our first like intros into this space, and it was an attempt to build an IPFS enabled peer into a mobile browser, and we did that, and we learned a lot. And so I wouldn't say that Textile is sort of like OGs in the strictest sense, because IPFS had been around for quite a long time, but we definitely were here before storing data for NFTs on IPFS was cool. So I consider that a pretty good sort of like OG status there. But anyway, we've been around for a while, probably at least 6 years. So in this talk, I'm going to refer sort of broadly to things like IPFS and IPLD and libp2p and multi-formats and all those concepts that go together to form the broader IPFS protocol and ideas as the interplanetary ecosystem. So if I say that IP ecosystem, that's what I'm talking about. Anyway, so we've been around, and so I've kind of developed multiple perspectives on the IP ecosystem in general, and I spent a lot of time in the sort of early days of Textile just really writing about the IP ecosystem, blog posts, how-to guides, giving talks, running workshops and discussions, and a big piece of that was driven by us coming in and saying like, oh my gosh, this like content addressable, like user-owned storage framework, this peer-to-peer thing, this solves a real concern and a problem that our team had, which was sort of user sovereignty of data on the internet. And so we just sort of dove in and said, well, can we build consumer apps on top of this right now? And how easy is that going to be? And so, as I said, we started digging into building things on the IP ecosystem, and Textile Photos was the first experiment into that. So we came in initially as sort of like an application user, having fun playing with IPFS, and a developer trying to build a consumer application on top. And we actually made some pretty decent progress on that. We actually built a mobile app that was spinning up and spinning down a IPFS peer on iOS and Android. And we showed up to the first IPFS camp with a somewhat working prototype. And yeah, you could also use it as a hand warmer. And that was pretty, you know, sort of useful side effect, but it worked. And this was pretty exciting. And it took us, you know, quite a lot of development time. And I want to say we could not have gotten to where we did even without a lot of the earlier work that like Open Bazaar and some of these other teams had done, where we literally borrowed open source code and figured out how to export, or figured out how to sort of leverage that and get it going on mobile. So like, this is the classic open source shoulders of giants sort of thing. But we demoed it there, and that was pretty exciting. And it took us quite a while to get to that point. And so at some point we started to move a little bit further down layers of the sort of like application stack to becoming more like protocol users. And we really got our hands dirty and started tinkering with, aspects of the IPFS protocol and developing, like sort of optimizations on top of peer-to-peer connections and blah, blah, blah. So we started moving a bit down. And then we kind of got a little bit further when we sort of decided, okay, that took us quite a long time to get to that point. Let's take a step down and become protocol designers ourselves and protocol developers ourselves, and actually start to build the tools that we wish that we had in the first place. And I've got a little story coming up that digs into that a little bit. But anyway, long story short, we've approached this, and me personally have approached IPFS and the IP ecosystem from multiple perspectives. We've participated in protocol discussions at most levels of the stack, contributed to specs for data exchange, identity, data representation. We've contributed documentation and all sorts of stuff. So we've been around for a while. We've been involved in that, and we've moved literally from the outside in, or from the top to the bottom of this ecosystem. And along the way, I have, I've formed a lot of opinions, and I'm going to share my opinions with you today because you're a captive audience, and I was invited. So there you go. So I've formulated a bunch of opinions along the way, and a lot of it is about how protocols and ideas get used in general. So like I said, I'm going to share those with you. And then at the end, I'm going to try and, allude to a little bit of what I think we need to focus on next. So with all of that in mind, main take home message. So, you can just basically stop listening if you really want for the next 20 minutes. If you take away nothing else, it's that I strongly think we as an ecosystem should, and kind of do, favor composability over just about anything. And when you're working and talking about composing protocols, this is a fundamental piece of or a way to approach things. And so I think the interplanetary ecosystem has got a lot of things right and a few things wrong. But one thing for sure that always comes up is this idea of composability is key. And I think that is something that we've gotten right, and that I hope will continue to get right. And so let's dig into that a little bit. Okay, so I said I was going to talk about opinions and time for a story and all that stuff. It makes me feel a little bit old, but that's okay. So here comes the story. It was late 2019, maybe November, maybe December. The Textile team was just back from an important team retreat where we were reevaluating what it meant to build real applications on the interplanetary stack. It does smell like smoke in here actually right now, just from the comments here. It does smell like smoke. And so we were sort of reevaluating how we were going to approach this stuff, and decided, and I kind of alluded to that earlier, that it took us a while to get to the textile photos product point. And so wouldn't it have been nice if we could have just spent less time doing that and bootstrapped a project like that more quickly? So we decided that some core building blocks are missing, and that what we needed was we were going to see if we really wanted to. I'm sorry, there's a child climbing on the roof of the Jeep here right now. It's a little distracting. So anyway, we decided there were some missing building blocks, and that we were just going to go build them. So that basically the next team that came along and decided to build a textile photos product would get there faster, and they would basically reduce what we were at the time calling time to failure. The idea here being, I want to test out an idea and see if it fails very quickly so that I can move on to the next big idea. And we need that happening a lot. We need that flywheel of application developments to go to sort of go faster and faster and faster, so there would be more developers coming in and building good products. And so that's what we needed to do to sort of like induce that mass adoption to DWeb. More developers building more things, failing more quickly, finding things that work, and moving on. And so we decided, okay, well, what do we really need to make a mobile application for photos and the other things we wanted to build? Well, we needed a database. We needed mutability. We needed identity, but that seemed really hard, so let's not build that. We needed mutable storage, and we needed a whole lot of other things. And then we needed it to be easy to use, and we needed to get it into the hands of developers that we were targeting. So we decided to move down that stack layer a little bit, and we started building those things. And we built ThreadDB, we built buckets, we built a mailbox API, we built all these things, we wrapped it up in the hub, we put it out there for people to use, and lo and behold, people started using it. And of course, we already had a large body of code built up from pieces of Go IPFS and Go OpenBazaar and other places. But we decided to start from scratch for this project. And here's why. We didn't need the whole kitchen sink for this, right? We didn't need IPNS. We didn't need the concept of pinning. We didn't need a gateway, or if we did, it was going to be a hyper optimized and hyper simplified gateway. We didn't actually even need PubSub. We didn't need mutable file systems. We didn't need a lot of these other things. We did need BitSwap or something like it. We did need DAG-based data structures. And in fact, the work we did with encrypted DAGs for ThreadDB, it led to a bunch of collaborations with other ecosystem members like Ceramic and Fission and other folks. And we actually worked on a spec with Ceramic for DAG Jose. It led to a bunch of discussions with the IPLD team and other developers. And it even helped to push the multi-base encoded public string format for the DID spec, the official DID spec. So in moving down this stack and making some of these decisions and getting our hands really dirty, we got into different layers of protocol development. So we did need things like this, and we were able to leverage those things. And so we're like, how are we going to do this? Go IPFS at the time was a sort of very large single monolithic piece of software that was a little bit hard to take apart. So at the time, we reached for a relatively new project called IPFS Lite. Still love that now and still interface with that now. And the cool thing here is we were able to take only what we needed and nothing that we didn't. And the key thing here, and this is the most important thing I think, is it allowed us to experiment with the Threads protocol really quickly. Like literally weekends of hacking got us to the point where we could start experimenting and trying things out. And the outcome of that early experiment and that really fast bootstrapping was a white paper and a reference implementation in Go in just a few, I wrote a note here for months, but I think it was weeks to develop the Threads protocol. And so not only were we interested in sort of like bootstrapping this flywheel of software development, but the composability of the protocol layers that we were working on made it possible for us to facilitate that bootstrapping. And then here's the other cool thing. We were also able to quickly move to implement IPFS Lite in TypeScript to help drive our TypeScript implementation of Threads. And this in turn to about 10 or plus TypeScript libraries that were published on Definitely Typed, and a bunch of discussions with IPFS dev core teams about getting TypeScript types into IPFS and libp2p. And those got our whole ecosystem, moving forward until we actually started to, get TypeScript types natively in a lot of the libraries. And now basically everything is typed. And so we were able to not only very quickly, because we only needed the little pieces that we needed to get going, pull together an entirely new implementation in a very short amount of time. But that implementation iteratively led back into updates for the rest of the ecosystem. So big thing there was that, as I mentioned, only needed to take what we needed. and we didn't have to take anything that we didn't need. But this wasn't just software libraries, right? This was actually the actual protocols and pieces of the IP interplanetary ecosystem, like multi-formats. Multi-formats were there, ready to compose with other things. So Threads supports its own multi-format and uses a bunch of components of multi-formats and multi-codecs and all that good stuff. libp2p, which I have a little aside about a little bit later, IPLD, all of these things we were able to leverage. Okay, that's the end of the story. So like any good story, I have formulated a bunch of opinions, which I will now share with you as an old IPFS, person. And my voice is, I'm keeping it a little bit more hoarse and low, thanks to the campfire, which makes it sound more authoritative. So here are my opinions. They're all here, and these are opinions that I formulated. Yeah, pro tip there, that's right. Yeah, inhale a little bit of smoke right before your talk. So these are my opinions. You can check them out there, and enjoy them. But I'll elaborate on them a little bit. So these are my opinions that when designing, extending, and implementing interplanetary protocols, we need to do these things. So I already mentioned favor composability over just about everything. Everybody loves Lego, and the pieces are really fun to play with. But it also means that I can play with them and stick them together in all different places. And this Lego analogy gets overused, I think, but it's pretty happy. It's a pretty good one. And this story I just told was a perfect example of why composability is so useful. Another thing is that we should make easy things easier and make hard things only just slightly easier. So, that sort of means like sane, battle-tested default. And I think my opinion there is foot guns are fine. We can hand people foot guns as long as they're locked up in a case, right? So if we can let them do some pretty wild things, but they got to know what they're doing. And I think that's a nice way to think about it. So foot guns are okay if you lock them in a case. Things into smaller things is really useful, but no smaller than necessary. Because if we had to build everything with those little oneer Legos, we'd be pretty sad about that, right? And I think libp2p and a bunch of projects are particularly good at finding that balance. I think as an ecosystem, we need to experiment so much more often, share so much more often, and argue so much more often, and then we'll still never be able to do it enough. And these types of sessions are exactly the types of things that I think we need to keep doing. The other thing is we don't want everything under one roof. This is a lesson I learned along the way when we were interfacing with different projects. And I was actually reminded of the importance of this recently when I was talking about a BitSwap implementation in Rust on Discord. And I said, oh, it'd be nice if there was one version to collaborate on. But Athena reminded me, I think that's not right. It would be nice if there was one place to go to discover where all of the implementations are, but many implementations are useful. Which reminds me, we need more implementations of everything. And there's the obvious reasons for that, which are like resilience and finding bugs, and different languages mean that you have different people contributing, and all the other reasons that we think like multiple HTTP implementations are important or multiple ETH clients are important, blah, blah, blah. These are all good reasons, right? Another one is I don't really like Go as a Colton language, so maybe that's a reason. But there are less obvious ones as well, right? For there to be multiple language implementations, we need very clear specs, which are improved as new implementations take off. I think also there's something around language-driven thinking, right? If I am working in a programming language that allows one thing, I might try and leverage or use that sort of thinking in my spec development. I think this is a lot like spoken language, right? It influences the way you think, or at least some people think that that's the case. But probably the language they speak had an influence on that. So like spoken language, software language might influence how you think about an approach. And so a new language might help us to think differently about how to design a spec. So for instance, I have no idea if this is the case, but Rust has generics, which maybe influences how we would implement, libp2p or some component in that, which in turn helps to better define the spec, which in turn helps to better find differences and potential bugs with the Go version, which in turn makes it more resilient overall on the network, which leads to an overall better user experience, which in turn brings in more users, which in turn helps to drive IPFS adoption and so on and so forth, profit. So all of these things are pretty good things. So software diversity is a thing. More implementations of everything are important. And we're so early now as an ecosystem that building things together, it's just like, it's silly. We don't even need to be thinking about competition or anything like that when there's folks all working together, because we're just so early still that competition is sort of like arguably an illusion. And you're about to see a figure that doesn't make any sense. That's because last night I was working around the campfire and I didn't have internet access, and so I left myself a little to do here. But this is a little aside that I wanted to talk about, which is, all of you just picture in your head now the classic XKCD comic of that complex open source stack, and there's the tiny little piece there. And ideally, part of this ecosystem, actually, we've got all of these little pieces spread out all over the place. And right now, I feel like libp2p is destined to be that tiny little piece that's holding up most of the future of Web3. And so having a few more implementations of that to weed out some of the bugs is probably a good thing. Okay, so I'm gonna start to, yes, thank you, Brandon, for the XKCD comment, yeah. So there you go. Those are Carson's opinions. Come up around a campfire in the middle of British Columbia forest. Take them or leave them. Let's see where we go. But what's next? If you think about that, more implementations. I know the sort of like Bitcoin world thinks there should be one implementation to rule them all. Strongly opposed to that viewpoint. The more implementations we have, the better, and for so many reasons that diversity is a good thing. I think the next thing we want to think about is focusing on scalability of the network, of our implementations, of a lot of things, but never at the expense of composability. I think that one of the big lessons that the Textile team learned when developing applications on top of peer-to-peer protocols is light clients are a bombing great idea. So we want to enable more and more light clients, and as a result, enable more and more heavy services. So these are these things where a light client can defer a lot of its peer-to-peer interactions and things like that to some super node somewhere else on the network. Doing a lot, this really does enable local first style applications. So let's have a lot of light clients and heavy services and everything in between. And then, yes, IPFS Camp 2.0, please. I see it's already happening. I expect my invitation in the mail shortly. Let's do that, because the more we get in front of each other, the more we're going to discover all of the commonalities that we're working towards solving. And for those of you who are around for IPFS Camp 1.0, the months following that were some of the most crazy in terms of the sort of Cambrian explosion of software that I've seen in a while. So these types of events really do make a difference. So thanks very much. Hello again from BC. Let's imagine what we can do next. Cheers.
Thank you so much, Carson. We have a question from the chat. Hopefully you can see it. I think we'll take a few questions.
What am I most excited about in the IPFS ecosystem right now? I think what I am most excited about is something that Boris alluded to earlier. And Boris, I'm really looking forward to you writing that blog post, which is, I do think we've sort of hit this point where IPFS has won. And now we're finally at the point where it's like not a choice. You don't have to think about like, what am I going to do? What am I going to, what application I'm going to use? And so as a result, I'm seeing a ton of application developers that are coming in, not having to make that decision, which means that time to failure is like so much faster. So the thing I'm most excited about is I think we've really reduced time to failure. And so new application developers coming in, that's what I'm most excited about. Also, Agricore was like mind blowing. I couldn't put enough of those head exploding emojis. So that's super cool. That sort of like level of application development where the protocol is starting to disappear that's exciting. Oh, Mauve asked that question. I actually didn't realize that it was you who asked, but anyway, there you go. That was super cool. Carson, what's your thoughts on breaking changes while keeping composability? Yeah, this is a very good question, I think. And I actually was going to put in one of my opinions that we need to be just a little more willing to break things. But we need to identify where we want that to happen. And I think that's a really great topic for an IPFS camp thing where we can yell at each other a bit and tell each other how crazy we are to want to do one or the other thing. Because the Textile team, I don't know, some non-semver change happens and I go, oh, I can't believe, so-and-so downstream library did that. But at the same time, I'm constantly thinking, wow, man, we're moving so fast that it's crazy to try and stick to these things. So I think my answer is, I don't really know, but that's a perfect question to have, or a session to have at a gathering like this. So sorry, I have to think about that more. Oh, here you go. Juan's talking about IPFS camp. Let's make sure we do this poll and figure that out. Time for one more cue. And then I'll stop talking. Or none. I can give you guys a view out the window of the forest. Why is not everyone using threads? I think it's a bit of a heavy-handed protocol for some applications. Two, we never did the full-blown light client that could run by itself in the browser for various reasons. And I think that would probably have increased adoption a little bit. But having said that, a lot of people are using threads, like to the point where we can't keep up with the hosted version of it right now. And so, 6 to 1, half a dozen the other, I guess. I think that we learned a lot from threads, and there's a lot of useful things, but when you throw encryption into the mix, no one solution works for everybody. That's a good one to say. Any plans on libp2p Lite? To be honest, I think libp2p Lite is libp2p is libp2p Lite. I love the layered design of libp2p. Like, as a software design, protocol design thing, I think it's quite beautiful. And so I can layer in all the components and all the protocols that I want into this one, swarm stack. And the Rust implementation is just so nice to play with. So I don't know about that. I would like to revamp the IPFS Lite for TypeScript version because that's super handy. That would be cool. Why is not everyone using threads, and more specifically, what is missing to be super successful? Let's chat about that in the chats.
Thank you so much, Carson. Everybody sitting muted behind your computers, clap. Thank you so much. That was delightful. And Carson, speaking from um, talking from BC in a van, I think you set a new record for dedication to getting a talk done at a workshop. I deeply appreciate it. Go enjoy your campfire. You have earned it. And so thank you everybody for taking some time here. So next on the agenda, we have a 10-minute break. And we're going to come back in 10 minutes. I've moved this schedule up a bit just to make a little bit, just so that if others have a little more time to go fast, or we can save a little more time in our workshop. And then, hey, if we have an extra 10 minutes, then everybody gets to go enjoy their Friday a little faster. So from here, we're going to take 10 minutes, and then please stick around, come back. Jarapo is going to give us a wonderful talk about a very incredible, like, harrowing story of when to do something really specific. Cool. So 10-minute break. We'll see you all 20 minutes past the hour. Thank you so much. All right, all right. I'm going to turn on my video, stop sharing, and move on to our next presenter, whose name I believe I have mistyped in the agenda or in the schedule. I apologize, Durapo. And if I'm pronouncing your name wrong, it's because I've only seen it typed on the internet a lot. But I'm very excited to introduce our next presenter. Durapo has been working in the IPFS ecosystem for some time on the IPFS Discord and has a wonderful talk prepared for us now. Durapo, are you there and ready?
Hi, yeah, thanks. It's fine for the name. The pronunciation is very good, so I'm happy.
Yes.
Well, I will share my screen and start then, I guess. You got spoiled, sorry. So hi everyone, I'm Durapo. I'm working at Protocol Labs as the developer advocate for IPFS. And I will tell you the story of something I've been building for IPFS, which is Linux to IPFS. So the main part of the story is not actually Linux to IPFS. It's mainly how it goes to happen and what lesson you can take if you want to make your own custom project. So the first problem I have is I'm a Linux user. I use Ubuntu and Debian mainly. And I wanted to be able to download my packages from IPFS because it's cool, and I believe that's a good enough reason. But no, it has practical application. IPFS do -1 scaling. That means that basically when someone downloads the data, they reshare it to other people's. And right now, the way Debian and Ubuntu repository works is they have a lot of mirrors, which are web servers around the world. That's very expensive. So obviously, the developers does not pay for most of them. Most of them are like universities that have a few gigabit of bandwidth free that host one. And IPFS would allow, like, instead of having lots of spread things, having one global network that everyone can use, which is very fast also. So what they are is basically just web servers with a lot of files. So the first step for me was getting the actual data for the packages, be able to create my own repository, basically. The first thing I tried was wget because, well, I have web servers, wget download from web servers. It didn't work very well, mainly because I couldn't find an easy way to have incremental updates. That means that often, like, the repo itself is very big, but it's not getting updated completely every day. Most of the time, only a few gigabytes are added per day. And ideally, I want to only download the new gigabytes, else I would be wasting my bandwidth. So I didn't go that route. Instead, I go with Earthink, which is a very well-known tool for doing that. And that's my command. That's my script. It downloads Debian and Ubuntu and Termux, and that's basically it. That's not what I have. And I have an issue, which is they are very big. Depends of your definition of very big, but I basically tried. Oh, yes, sorry, my setup. So for the context, that's an NAS, which I built of recycled hardware. Only the HDDs are new. Everything else is very old hardware. And that means that when I tried adding it to IPFS, it was very slow. It took more than a week, and it was not faster. Like, every time it took more than a week, and the repos update more often than a week. So I would always have to catch up and be very old with, like, if you assume you want to download security patches, for example, having them a week late can be devastating. So that was not a good solution. And then I will, in my explanation, give you some tips about writing fast software. The first one, the most important one, is measure. Really, you might think you know why your software is slow, and I can tell you by experience, no, you don't. It's incredible how many times just profiling showed me how I was wrong about my assumption about what was slow, what was fast. And that's the first rule, like, you need to bottleneck. So the bottleneck, doing benchmarking and profiling IPFS, there are many tools you can use, but basically the conclusion I came with is IPFS was not really playing well on I/O. The main issue, I believe, were my disks, which were hard drives, And the issue with hard drives is they have poor random reads. And I'm not actually sure this was the issue, but that's why I try to fix. So to doing that, the first rule is only do the work you need to do. That's the first rule for going fast. And the way I think IPFS fails at this, for my precise case, is like it's a very complete thing. You can use it to build lots of application. And the main issue I have with the way I was building it is it's kind of built around a daemon model, which so like you have a single service that communicates over an API, which is often HTTP, and that add lots of overhead, and that prevents some optimization I wanted to do. So to do that, I created Linux to IPFS, which is a custom tool I've made, and it's really small. And the main part of it was I needed it to be easy to experiment with. So like it's one file, one single main file. It's about 1,000 lines of code, and it only has one job, which is taking the files on my hard drive and uploading it to an IPFS node, which right now I use Estuary because of convenience reasons. But for example, Linux to IPFS doesn't know how to do bit swap. It doesn't know peer-to-peer. It doesn't know networking. But I don't really care. I want it to add files to a node, and that it does really good. So the way it works, the main point of it is the recursive function. That's really the heartbeat of the code. And to do that, it's mainly what you would think you would code something like that. So I give it a path on my hard drive, and it will scan it, see what is it, and depending on the type, it's gonna do different things. So basically, I have a small example on the bottom right. Let's assume it's adding this directory. It would first start here, see ABC, add ABC, and create an empty directory block. Then it will repeat. So like the recursion on this step is finished. We enter in foo, we recurse in foo. We enter in foo, we recurse in bar. Then we take care of buzz and high, which are the files, so that we write it to the output car file. And once buzz is finished, we then go to high. And then when high is finished, we go back up the stack, so bar, foo, and top. And we have finished and we have added everything. I don't want to spend much time on this because it's really like the canonical way of implementing it. That's the different way. The main, so the second rule of going fast is doing chips check first. One issue IPFS was not doing it from is I told you Linux repo updates a few gigabytes per day. However, the way IPFS, sorry, I should have put Go IPFS, but Go IPFS handles this is it hash everything again, and if it finds the same hash, it's not going to restore it. But the issue is that means that I have to hash everything, and I have to remind you this is all hardware with a terrible CPU. I don't want to do that. So the way I get around this is by cheating a bit. So most file systems support modification time, and that allows me to basically compare a file. And if the modification is older than the last time I've updated it, I know that the content haven't changed. So I just reuse the CID I got from the old one. So I have an old.json file, which are all my old CIDs. And I use that to skip adding files that have not been added. That's also good on bandwidth because I don't have to re-upload the whole repo every time. To Estuary, I just upload the new files. The fourth rule of going fast is using your resource to your full potential. One issue I believe Go IPFS has with my hard drive particularly is hard drives are kind of fast compared to SSDs, but the main point of SSDs is not really that they go fast, but they have a very low latency, and hard drives have terrible latency. And so the issue I was running into is basically most of the time I was waiting for the disk to stick to a certain place. So the way hard drive works is they have a head that sticks around the disk, and most of the time was spent doing this. And the way you can fix this is by adding ref linking. So instead of like having to copy things back and forth between my files and my destination, what I do is I ref link the data. So that's a feature of newer Linux kernel and BTRFS, the file system I use, which allows me to create a copy on write copy. That means that the data is not actually copied. What it created is only a tiny, tiny block on the disk, which says this file, like the new destination, points to the data of the old file. And if anyone modify the shared data, if it just modifies the block on the disk, it will modify it for both files, which I don't want. It's kind of because else the data would get corrupted. So what it do with ref linking, if someone would write to that shared piece of data, it will create a copy of it and write to the copy instead. And that's where most of the speed comes from, because I skip copying the data. I only have to read it, and I write a few metadata, which is like megabytes for the terabytes of data I have. The second thing is, with IPFS, I could not find an easy way to send the data to estuary while I was traversing it. So I had to first do the IPFS add, which takes weeks, and then upload to estuary, which could potentially also take weeks. So what I did is I used this small representation. On the left, we have the traversing module, and basically it's going to send the data by 32 gigabyte blocks. So it creates a 32 gigabyte file, and it's going to send it to the Sun module. And they both work in parallel. So the traversing module doesn't have to be completely finished. It can send smaller chunks, and that allows them to work in parallel. And that's also very nice, because then, like, basically the total time is whoever of them is the slowest, because the other one is just going to run in the background. So right now, and that also gained a lot of speed. The issue I had doing that is I had to split my DAG into multiple blocks, and that didn't really work out. So estuary wants full DAGs, and full DAGs. That means that if I send a directory, I have to also send all the files and the subdirectories, and all the sub-files in the subdirectory, and all the way down through the DAG. So I have to send everything complete, which is exactly what I don't want to do. So the way I got around doing it is something I call the leaf hack. So in the left to right, we have the actual DAG as I'm creating it. And from the top down, we see the DAG I sent to estuary. So the main difference is when I send the DAG to estuary, I'm not giving it the true CID. I'm only giving it raw CIDs. And basically, a raw CID is just some bytes, and it doesn't have any encoding. It's just the bytes as is. And the way it works is I send the actual bytes, the same serialized byte, but with the raw CID. So the hash matches, and if someone so estuary is getting the fake root, which is smaller blocks of 32 gigabytes. But if someone wants to use the real root, which is far bigger, it still works, because when this person downloading the real files is going to ask it to estuary, estuary doesn't care that the codec is wrong. All it cares is that the hash matches. And that's where I can get around splitting my files in smaller chunks. And that's not only about speed, and that's also because estuary has a limit of 32 gigabytes because of the file count sector limits. And this way, I'm also getting around the file count size, and I can split around multiple sectors, file count sectors, to store the data. The last thing I did to greatly improve performance is parallel chunking. Instead of just having the traversor doing one block at a time, I now spawn a lot of different chunkers, and that's only on one file. But that means that instead of working on 2 megabyte blocks in the file, I now can work 32 times 2 megabyte, and that's very good at generating big queue depths. I told you before that hard drives are slow, not so slow, but they have bad latency, and that's a way to get around it. Basically, since I'm now asking the kernel for a lot more data, basically like 32 times more, the kernel has much more leeway in which data it can give me first. And the kernel is able to optimize the seeking pattern of the hard drive far more efficiently. And that's giving me better performance because I am using more performance of the hard drives by asking more of them. And so now I have an architecture kind of like this. I have the traversor that creates a chunking job, and the chunker and the traversor send the blocks to the sending module. And all of this works in parallel, which helps getting faster. And so the final result of all of this work was before, where on IPFS, an add will take 1 week. For adding the same data, it took 1 hour and 30 minutes. That's for a full flush, so I have to add all the data again. And if I do an incremental update, that means like we have 1 gigabyte of new file, but everything else is old. IPFS still take 1 week because it doesn't have any special case. It's just going to rehash everything. And Linux to IPFS is going to take 15 minutes. I can improve that number, but basically that's very good. Like I still think for That was, for information, this test was doing hiding the terabytes, the Debian repository, which is 1.8 terabytes. So I think that's pretty good. And also, one neat thing is like, this is actually faster than the write speed of my disk, because my disk can only, I don't remember the actual number, sorry. But because I'm using ref linking and I don't have to do the copy, Linux to IPFS create a fake copy, like a copy with quote mark, copy on write. But since like I'm not actually moving the blocks on the disk, it's able to write faster than the actual write speed because it's not writing. So again, the first rule of like not doing work, since I'm not doing the copies, that's faster. The future plans, I want to make it actually usable. It doesn't actually work for hosting Linux data, mainly because I have an issue with symlinks in the gateway. And when the aptitude, the Debian package manager try to fetch it, it doesn't really understand. Basically, the package manager and Go IPFS gateway have a different idea of what should happen with a symlink, and they don't agree and it doesn't work. Making faster, most of the, so there are multiple points that could be improved. All of them is about the zeroth rule of making the code faster. This is thing I measured that is actually slowing down that's basically my current bottlenecks. So statting is slow. So if I go to traversal, I could accelerate statting. Parallel uploads, because the pinning service is very slow. In my case, that's the main bottleneck. Blake 2, because if the pinning service is fast enough, then my CPU is slow. And yeah, so all of these could improve it. Better UX and remove bugs, because it's buggy. I don't actually recommend you use it. And the main point of this is not to tell you, hey, go use Linux to IPFS is great. It's not. It's buggy code that it works for me because I wrote it, but I'm not really sure anyone should use it. The main point is like, this took me about 5 days of work to make. Doing the same optimization in Go IPFS would have been very, very long. And that allows me to save time by concentrating on what I wanted to work on. Again, it's 1,000 lines of code. If I want to do those changes in Go IPFS, since like there is far more features, there is less attention I can give to each feature. Since Linux to IPFS has very few features, I can work more on polishing them with the same amount of time. And all of this is possible to docs and spec, really. The hard part is understanding what you want to do. But once you kind of know about what's an IPLT block, why do I want to do X and Y, read the spec and implement it. It's really easy, I think. Once you get like past the first understanding hurdle, actually writing your own implementation is surprisingly easy. Just read the spec and do what they say and it should be fine. And yeah, that's finished. If anyone has questions.
That was fantastic, Drapo. Thank you. I will ask my question because I have the power to just speak. This seems to me like a great example of what you can come up with when you narrow down the platform and the use case. And you've gone really far as a solo dev on this. My question is, how do we cycle back this lesson that you've learned? Like, how would you see the conversation moving forward between a project like this and affecting maybe the design of Go IPFS?
So I'm trying to work on getting ref linking into Go IPFS, but that's hard because, like, basically Linux to IPFS code is awful. Really, it's bad. It's ugly. I don't recommend anyone using it. But that's like, we have standard for Go IPFS, and I cannot do this kind of stuff. I think the main takeaway here is sometimes it's just faster to do things from scratch. If your goal is kind of small and you just care about your own stuff, like, for example, I only improved the actual chunking part. I didn't do networking because I didn't knew how could I improve networking. So I concentrated on what I knew I could improve and made my own, and that was faster. And I think sometimes people will have an easier time just writing their own protocol instead of using PubSub, or I don't know. There are various examples like that where talking to people, I think just make your own peer-to-peer protocol, or just write your own block store or whatever. And probably people will have an easier time if they, in their mind, like, sorry, but my one is not very clear, but it was really surprisingly easy. I was thinking it would be like 1 month of work that would be spread like a long time. No. In like one day I had a prototype working, and most of the day was just optimizing the thing. So it's surprisingly easy. Again, you can just go and experiment and should be fine.
Fantastic. Thank you. I think we have time for maybe one more question. Anybody in the chat? No? Thank you very much, Drapo. A round of applause, everybody. Thank you.
Thank you for your time, everyone. I was happy to talk.
Appreciate it. Yeah, it's very much appreciated. And we're going to keep this good train rolling. We're going to move on. Dietrich is up next, and Dietrich is going to talk to us about IPFS everywhere, what's worked, what hasn't, and what you should build next. Dietrich, are you ready to take it away?
I am. Can you hear me?
Yes.
And here are some slides too. Hey, everybody. Really thanks, Brendan, for setting up this day. It's a super important conversation. It is something, as you will find out in this set of things that I will share with you, is something that affects me and my team's ability to do our jobs every single day. So if I don't know you, even though I know most of the people here, my name is Dietrich. I've been working on IPFS related things for 3+ years now, and maybe a little bit before that, worked on browsers for a long time before coming over into this wonderful distributed Web3 world. And I lead the browsers and platforms team at Agricore Protocol Labs. And here's a sampling of some of the things that we're doing this quarter. As you can see, we work across a number of different areas, but the common denominator is really that we put IPFS into strange places where it is currently not. That's everything from browser integrations to different mobile use cases, a lot of grants, like I'll talk a little bit about Mauve and the work that you saw earlier, why that's important, as well as things like open source tooling, operating systems, and use cases like space, metaverse, and IoT. So lots of places that I think I would consider them hostile environments to IPFS as it's designed and implemented today, which is really challenging. So I'm going to talk about some of the work that we've done, what's worked in these initiatives, and what's been challenging or hasn't worked in these initiatives, and close with just a couple of thoughts about some of the gaps we've identified and some of the things that should be built next as all of us kind of come out of this conversation, think about what the next steps are for IPFS adoption to really grow unbounded by the limits of the very few implementations that we have today. A lot of the work that we do in this particular team, and even really like the work that I've done since joining Protocol Labs a few years ago, is about talking to people that think about technology and the work that and the software they're building every day, pretty much like this, where it's a request, a response, and even when they're working with IPFS, oftentimes it still looks like this, which is really, really challenging, and often means that we're trying to figure out and negotiate how to add something that is paradigmatically different into their environment, and sometimes at their behest, sometimes to address a use case or a business need that they have, and oftentimes too because we think that that particular space they're working in would be enhanced or improved, or their users would benefit by the addition of IPFS as something that is available and choosable to developers in a given environment. Because when you add IPFS, you end up with a topology that looks a lot different, with characteristics that are different, with use cases that are different, and architectures that are radically different than what people are used to building today. There's a whole bunch of different challenges in doing this. Technology has momentum, and it is very difficult when adoption reaches a certain scale to change behaviors, because they became integrated and embedded. The tools that we use every day have a bunch of these kind of assumptions built into them around what the security model is, what the privacy model is, where data comes from, how it moves between different systems, how fast or slow, and even out at the glass, and user features are designed with a bunch of the constraints of existing technologies in mind. And that's actually one of the bigger challenges from reorienting people around what IPFS can do, is the fact that they assume a certain set of behaviors or capabilities that are constrained to the given network implementation or the network architecture, the underlying protocol, which are really not true anymore. There also might be new challenges that they have with these new architectures, new constraints that they're not familiar with as well. Like in most Go IPFS APIs, where you make a request that never really truly ends. It can just keep trying for as long as there's people left on the network to ask for a given resource, for example. So a very big paradigmatic difference from that, where you make a request, get a response, call it a day, move on. One of the challenges that we have in terms of getting things to work is oftentimes these are not technology challenges in IPFS adoption. These are cultural challenges in adoption. Sometimes these are cultural challenges in terms of the technology norms and the tools and the platforms, architectures, and patterns that you're used to, but also challenges with thinking about distributed networks and what they mean at the political, philosophical, and even sometimes moral level. And these are some of the challenges that we have with even really big groups, everything from browser vendors to standards bodies in adopting IPFS. So it's not oftentimes just a technical challenge of a given implementation that can be problematic or is a point of negotiation. And this is something that I really, and I'll tell this story to really underscore this in a few different ways, but really cannot impress upon you how serious this aspect of the transition from centralized technologies to decentralized technologies, how important this aspect of it is and how much important it plays. So I'm going to start by talking about the web browser work that we do. Here's kind of like an overview of some of the bigger web browsers today and their status in terms of implementing or adopting some of the technologies that we're talking about, IPFS in particular. As you can see, there's a surprising amount of green here when I actually wrote this up, which is awesome. But at the same time, it's complicated. These oftentimes are specific relationships. We'll talk about a couple of them and challenges. And sometimes people feel like they can talk about it, sometimes they can't. And we have talked to a lot of folks at the major browser vendors, and there's IPFS is definitely increasing in recognition. People at least know what it is. Recently, the CTO of Mozilla wrote a post on his private blog, not a Mozilla one, talking about IPFS and Beaker, which was really a step forward in terms of getting the attention on these types of technologies and the type of capabilities that they offer to the web and some of the challenges that they pose. So that things like that are I think what we'll chalk things like that as a win for our team and for the adoption of IPFS generally. It's just having those conversations. It's really complicated, and we do even at some of the bigger ones, even Chrome. We have folks that are we sometimes read signals, right? Like Google hasn't said anything about IPFS publicly, really necessarily, or supporting it in Chrome. You know, we're working on Chrome support, but we're getting really good turnaround times on code reviews for PRs, for example. So these are the types of kind of tea leaf reading that we do sometimes. Brave shipped IPFS support last year, and this is one of the biggest, I think, victories of IPFS adoption in larger scale applications. Brave has over 50 million users monthly right now and growing really, really fast. So this is a really big opportunity. IPFS is available to over 50 million people in software that they probably use daily or pretty close to it. They implemented the support for the protocol and also bundled the ability to optionally turn on a support for a full node of Go IPFS so that downloads Go IPFS and starts running it. And there's some things that worked here, which is, you know, again, it's not all technical all the time. We had willing, enthusiastic collaboration with them. They're super interested. We embedded an engineer full-time in their team. We made a bunch of decisions around the user experience of IPFS and how it's presented to end users, off by default, very, very clear privacy warnings. And then we experimented a lot. Like the first thing that they shipped, what it looks like today is pretty different. We made a bunch of UX tweaks. We had to change a bunch of things around how the address bar is constructed, designed, and what it communicates to end users. We shipped a kind of light option on by default with the full option off by default and the ability to configure that. And then like kind of this cascading set of user interface pieces where people could, if they ran into IPFS stuff, they would be presented with these types of options. So being very, very careful is something I think that really worked here. A lot of the problems are, how do you visualize how strong your connection is? the IPFS Go IPFS node approach is really about peer aggregation and bandwidth and kind of like bandwidth available, but pretty much just peer aggregation. So there's not really any norms or design language or kind of UX work that's really been done around how to communicate things like that, how to communicate trust, when trust is defined by the fact that with content addressing and IPFS, it means that nobody has modified the content that you've asked for. You receive what you asked for, and you are guaranteed that by the protocol. However, the traditional web approach to trust is that the website that you loaded was granted a DNS name which is encoded into an SSL certificate, which you can walk the SSL cert chain all the way up to a certificate authority, and the combination of those things and the browser having that CA cert integrated into it means that you can trust the website. So the way trust is defined is radically different. It means very, very different things to end users, and in specific use cases, how do these things live together? How do we communicate them? Still very, very much undefined. And I think one of the biggest things that has been a problem for a long time in IPFS, which was exacerbated when you actually gave regular people access to a full node, is where's my stuff? With a website, your stuff is on that centralized website server. With IPFS, maybe it's in your node, maybe not. It's pinned, it's not pinned. It got garbage collected. Maybe it's somebody else's node. It's out there in the data soup of the distributed web. Very unclear. And so each one of these things is a learning for future implementations and approaches that we take. We've been working with Galia on Chromium fixes for quite a while now, and really moved from sort of like web compatibility fixes around the security model for local host access and things like that, into more directly addressing what IPFS support would look like in Chromium. And there's basically not really any way to easily bundle something like IPFS and Chromium. What Brave did, while is incredible achievement, is also not really the end state that we need to be in for a broader adoption of what IPFS implementation and native to the web platform would be. So some of the things that have worked so far in this partnership, in a community that is generally skeptical of Web3 stuff generally, crypto generally, of where the kind of like security, because of the security and privacy assumptions and models of the web today, of Web 2, the IPFS approach is treated very much with skepticism and frankly is considered quite dangerous for a bunch of use cases. So things that have worked, going very slowly, being very understanding and aware of the concerns that people have. A very credible partner that has, Galia has commit rights on Gecko, WebKit, and Chromium, building up trust by working on web compatibility stuff across all three browsers, not just going, let's, like bolt IPFS onto here and as fast as we can, focusing on the re-architecture of how Chromium supports non-HTTP protocols generally, not going full IPFS again, and then really, working to cultivate relationships with the communities and the people that we need to be able to collaborate with, and get code accepted and proposals accepted, and be to who would be embedding or bundling IPFS in their end user products as well. Things that have been really challenging, this really HTTP blinders up and down the Chromium stack. It means it's going to take a while to do this work. It's not just a throw a bunch of engineers at it and see how fast we can go. Really, the network stack that we have in Go IPFS today and the libp2p approach of pure aggregation isn't really functional for most desktop class computers. Browsers today, or at least for desktop web browsers as they are today, desktop web browsers don't really have listening sockets. They don't have, they have transient connections. Sometimes they have persistent connections, but a lot of that is also not really at the protocol level. It's handled by, like in Chromium and Gecko, it's an entirely separate network process. It manages all that network communication. So anything that is doing like network activity outside of the bounds of that architecture is really problematic. So we really need to rethink for broader and native IPFS adoption in the web platform, kind of what the network architecture looks like. And I'll talk a little bit more about that and how this is a recurring theme in the work that we're doing. IPFS Companion is our browser extension. This is another vector for us to be able to get into web browsers in an interesting way. It was interesting and it's getting less interesting. The kind of surface area of capabilities and APIs and things that you could do with a web browser extension is reducing over time. It has, with Manifest v3, which is a new version of web extension APIs and architecture, how web extensions, browser extensions are created, pushed by Google and now adopted by Mozilla, who's expecting to ship this by the end of the year in the latest update. It really reduces what you could do inside a web browser. It offers up some new interesting opportunities too, for us to be able to add things like protocol support in a way that is less of a battery and CPU destroyer. So that's actually going to be nice for browser and user experience, which is really important, but also pushes on us the need to really radically re-envision what the architecture of IPFS in a web browser actually is going to be, and what it needs to be. So there's challenging there. We've rewritten IPFS Companion from scratch in the last couple of quarters. So we're ready for this transition, but we did have to remove features that we had before. And whereas I think at one point it was really thought about extensions might be a vector for native, like channel through which we could implement more native IPFS support, that opportunity is just growing smaller over time. And we really expect that even a lot of our partners will actually be pushed out into kind of a companion type of approach where we have a local node doing local HTTP or IPC over to that local node somehow. Mobile is an area that we do a lot of work in. You saw, Mova's doing some work on mobile with Agricore, and one of the groups that was really early in experimenting with mobile is Birdie, and Birdie implemented a very interesting approach of embedding Go IPFS entirely with Swift and Kotlin bindings, so you can more easily embed Go IPFS into mobile applications. And while this was an incredible achievement, again, similar to Brave, very early on in the kind of maturation phase and adoption of these technologies, very much a bolting on of something that doesn't kind of natively fit in. They also implemented a libp2p transport for not just Bluetooth LE, but kind of like a suite of different platform specific approaches to proximity communication and detection, including Bluetooth LE and some other things. And they've been experimenting with kind of this higher level patterns of proximity-based connections that is going to be really, really valuable in the long term, I think. And something that worked there was having a team that had a very specific use case. They're not doing anything broader IPFS related. They're focused on their private messaging app, and they're really using that to drive development. Kind of the same approach that we saw in Jerobo's talk earlier. This like focusing on a very specific use case and spiking on that in order to be able to get some really important learnings and things that can be applied to the rest of the ecosystem. They had a very specific focus too on local and offline technologies. And they also have really taken a kind of slow development approach intentionally, working directly with their community, working and getting constant user feedback, which is very different than a lot of teams where they're like, all right, we're not going to talk to users. We're going to sprint on this code, get it to where we think it is what we think it needs to be, and then ship something. They've really taken kind of the opposite approach there. And only recently, I think, even opened up public betas. A lot of the challenges are that they're kind of going against the grain of the architectures by putting Go IPFS in there, the native architectures, the network architectures of the devices they're embedding in. Really choose a lot of mobile device resources. And the kind of like the process that anybody who's tried to use Go Mobile IPFS integrate with their application, that build process is pretty tough and pretty tricky to get right. They spent a lot of time working on that because of that non-native alignment and integration. Durin is another recent project that we've been doing with a company called Trigram, partnering on a different approach towards native IPFS applications on Android and iOS. And this is really the opposite. Like, how do we integrate basic IPFS and user tasks into mobile operating systems in a way that aligns very closely with their user model? Like sharing images, publishing images, receiving images, things like this, like basic things, documents, loading, opening IPFS scheme URLs or URIs, things like that. So is exploration to these types of things. We've got a bunch of things working so far. It's been really good to start small. It's really worthwhile to align very closely with the user model of the device that you're embedding IPFS into, thinking about the user tasks that are most common to daily things that we do. And that's really helped us in terms of being able to figure out how to prioritize those features, what works and what doesn't, being able to like relay the IPFS scheme out to any other applications or handling that application intents and things like that has all been really good. And I think we're going to actually end up probably with kind of a daily driver type of application for working with IPFS data and services through this application over time. Some of the, those are the things that worked well. And there we went the opposite from Birdie. We didn't go full, and Agricore, we didn't go full IPFS, just really limited bits based on what the available operating environment allows us to do. Where do we go from here? Does it end up looking like a full browser? Is one of those challenges. Like, where do we take these learnings? How do we apply them? How do we get more people to be able to copy and use this code, this approach, and some of these learnings? Agricore, you heard from Move earlier. I'm not going to spend a lot of time here, but I do want to underscore how important this work is. This is one of those things where we really learned a lot so far around embedding, modifying and embedding Chromium, and also with a little bit around what the benefit of being driven by a specific single use case and community. So the things that worked were that really like laser focus on a specific use case has actually resulted in application model learnings of the kind we're seeing with their little microblogging application. And the integration to web platform itself, as opposed to trying to route around the web platform with things like localhost URLs and stuff like that, that is real, honestly, like just in this small grant, in this small period of time, we've learned more, I think, about what an application model for IPFS would be than a lot of the previous work where we kind of like bolted on or routed around. So it's been really valuable. When it comes to challenges, Mav wrote a really long post, which the first of a couple, really detailing kind of like just what it takes to build a Chromium fork and ship it on a mobile device. Is really worth reading. So we're really excited about the outcomes of the work that's going to happen there. Capiloon is a mobile operating system. This is based on KaiOS, which was originally based on Firefox OS. And they forked the updated version of KaiOS, which has much more recent versions of Gecko inside. And we did a grant with them and to add IPFS features. And what's interesting here is that they ended up, one, you have a mobile operating system that's almost entirely web technology based that has IPFS and IPFS support. And they're also using IPFS in the making of it. So things like build distributions, when you actually download the pre-builts, if you've ever done mobile operating system development, you have to download all these binaries that need to be put on the device. So they're using IPFS for distribution of that, which has been really interesting. Having full control of the OS stack, where we have a lot of like, basically do whatever we want on that operating system, has been really interesting for learning about embedding. And it's going to be a great place for us to experiment with re-envisioning what a native IPFS would be on these devices. Some of the challenges are really like a bet on Gecko isn't really great at this point. Mozilla is not really supportive of these kinds of efforts right now, and definitely not around Web3, not supportive at all. They've hit some issues too, and I think this is a blessing and a curse. While using IPFS for the building and distribution of the operating system, they're also hitting a lot of problems where they're pinning to our services, like to interesting services like Estuary and Web3 storage, but then pulling them through the gateway and hitting problems. So they're kind of like regularly relaying issues that they're having, which is making our services better and the gateways better, ultimately, which is good, but it's also challenging for them. We've definitely hit the network architecture problem here. Private data is actually something I didn't list here. There's a really important use case for mobile devices. And then I think the last one is, again, like, what is an IPFS application? We don't have an application model. It's a data layer and a protocol that can be used in infinite ways, but that kind of without having a higher level security model, privacy model, features and capabilities, permissions model. It's a new set of challenges to be able to answer those questions when designing an application. We've been doing a lot of open source tooling integration too. We recently got FFmpeg and MPV support landed. And this has been fascinating. One of the things that worked here, again, like not going full IPFS, like meeting the community at where they're at, having this was months and months of negotiations and conversation with that community to figure out just the right set of environmental variables to be able to configure what the fallback and connectivity schemes are. We had learned a ton in the challenges section here around how and what to communicate to users about what it means when they're using IPFS, how to detect and fall back to local node, be able to or fall back to gateways while trying for a local node first. And hopefully that we actually start out of this work to standardize on a little bit for open source tools and libraries what this IPFS integration could look like across a broader base and maybe eventually operating system integration. We're working on curl as well, and there are patches there. And interestingly, like really quick, when you're trying to get other people to adopt your stuff, or add your stuff to their stuff instead of them getting to use your software, which is really different dynamic. The curl maintainer Badger immediately was like, I can't find this stuff. And you could point it to our IPFS specs repo, but if you ask anybody that works on the IPFS project, they're like, no. Don't look at the IPFS specs repo. The Go IPFS code is the reference for the spec. So we have a really complicated situation for even people that are supportive and interested in adopting IPFS when pointing to our own specification for the protocol, which is really a really big challenge. IPFS Tiny is another interesting and different implementation approach. This is a C++ implementation of bits of IPFS. So far, they've gotten all the way like addresses and IPLD, and I think IPLD started working last week. This idea is to run this on embedded devices, and also some of the work that we're doing with space industry. And what's worked, we're not totally sure yet because we haven't deployed this code anywhere. Not trying to do libp2p at all so far has worked, and that they've gone farther in the construction of the core libraries and things like that. And honestly, these devices that we're looking at aren't going to be able to run full libp2p anyway. One of the biggest challenges in this kind of work is the first question everybody's like, why C++? And every time I hear that question, I have to be patient and really explain kind of the dynamics that we have and in getting people in meeting people where they're at in order to be able to increase the chances of adoption. The embedding world is almost entirely C++, and people are, why not Rust? And Rust in embedding is, while it's way more mature than it was 3, 4, or 5 years ago, it's not the default. It's very far from it. And the number of production devices, when you're thinking about like hundreds of millions of devices being manufactured and shipped, software change in that type of industrial scale is very, very slow. So we need to be very, very careful. And people who are going to be making adoption choices around protocols are going to be using C++ for what, another decade, 2, 3, 4. So while we're also doing some work in encouraging embedded Rust use where we can, things like this, like these are embedding experts who work in space industry and connected device industry. And for them, it was like we had the conversation, and for them, it was a very clear choice that the C++ was going to be the best. So sometimes the biggest challenges are our own communities who think they know better about a whole given industry or environment or area, and aren't really interested in this particular the approach towards implementation. Finally, one of the areas that we're pushing on right now too is space industry, where there's a bunch of different use cases where kind of like offline local first by default data architectures, configurationlessness and nodelessness of IPFS when you're able to refer data by content addresses instead of locations. Also very, very powerful features when it comes to very slow, dodgy communications and very expensive data communications platforms. Or you might have space-to-space devices that need to kind of like have loosely coupled data connections and interactions. IPFS, again, very, very powerful way to address some of these use cases. Things like aggregating data across when you have like, 4 6-minute windows of data availability today as satellites are going by. Things like IPFS and be able to refer to larger data sets in aggregate across a number of disparate ground stations is going to be really interesting. And we're going to do some tests hopefully in the next year with different groups who are interested in this. And again, like, I don't think we know what's worked well yet, other than assuming we know so far that the network architecture of our current implementations is a non-starter, really, given the constrained network environments that we need to operate in. Some of the other things are unsurprisingly, aside from highly constrained environments, are really highly proprietary code and companies that are and people that are used to working under that type of secrecy and operations. So we'll be able to share more, but I think it's really going to push on our assumptions around what the network architecture of IPFS needs to be. So that's pretty much the tour through some of the challenges of things that have worked, things that haven't worked, where we've taken the current implementations and sort of jammed them into environments where that are maybe hostile to it for a variety of different reasons. IPFS does not have an application model, and that technically neither does HTTP, but the unbelievable success in the web platform of being in everybody's daily life almost all day, every day, has made that application model and really made clear that having an application model that kind of like very clear, idiomatic, that is agreed upon by notable parties, standardized, interoperable, really increases the chances that people can build the things they need to build and that they can do it in ways that are safe for their users. And so the development of that application model and the integration with the web platform at some level, I think is an incredibly important area of work for IPFS adoption and a gap that we have not yet filled. But we're making some progress there. IPFS implementation today, I think, is inverted. Like we really, by developing a node first application where we say you run a node, that has really been probably the biggest point of friction and even getting people that really are excited about it to actually be able to adopt IPFS. We need people to be able to add IPFS to their stuff instead of forcing them to run IPFS and then figure out a way for IPFS to interact with it. The local HTTP API approach is really cumbersome, even though it seems like it wouldn't be. It causes a lot of issues. Local HTTP connection isn't well supported in the web platform anyway, and that's one of the things that we really pushed on the edge of on our work with Galia. And we have it; it's better than it was, but even still, like WebKit won't make some of the fixes that we need for it to really work. There's not enough libraries from the communities developing libraries for languages themselves. And I really want to make clear that distinction. Like, it's not that we can go and we can write a library for Python, but like our Python library is kind of unsupported. We don't have anybody really pushing on making it better. Maybe just people doing fixes or chores on it. And so we're not meeting the needs at all. There's not really a reasonable choice for something that is native and idiomatic to Python, for example, the #2 programming language in the entire world. So that is really a huge gap, and we're really in investment and strong ownership and partnership and collaboration with the communities who are building their stuff in their way, as opposed to trying to get them to come to us. I think language elitism is also really, really challenging. Like thinking, well, why would you implement IPFS in JavaScript when you could do it in Go? It would be much better for that. I really believe that when it comes to technology adoption, there's no best tool for the job. There are choosable tools, and developers choose the tools that are available to them. And there's a bunch of availability can be defined in many different ways. What is the language I know? What is the operating environment that I have to run in? Not the one you would love for me to run in. There's like all kinds of reasons why people make choices make technology choices and adoption choices, and you need to understand the reasoning behind them. And oftentimes that is not the lead engineer of Project X deciding what the best tool for the job is. This is especially true for something that calls itself a protocol, but we have to be choosable in all of the environments, and that's how HTTP won. We need to be like water in that same way. Transport agnostic cannot mean only libp2p. And I think this is one of the things that is like, when we talk about IPFS, oftentimes we're talking about libp2p, especially when we're talking about challenges, when we're talking about code that people don't, and APIs people don't really understand how they work, the high dependency on the public DHT and things like that too. And without strongly decoupling these things when we talk about them and really treating IPFS as something independent of libp2p, where libp2p can be used for the transport layer or for the network architecture layer underneath IPFS, we need to be able to have other alternatives at the network layer. And then finally, the idea of transient network connections versus persistent peer aggregation as a model for connectivity and improving the chances that a given request will actually succeed for data. I think that model is fundamentally problematic for most places. Like even when it comes to private data, like we're seeing lots of groups put encrypted data on public networks, which is kind of a non-starter for a lot of security professionals. So we need to be able to have models where you can have an IPFS connection, maybe between 2, 3, 4 peers to be able to exchange data and then shut that network down, or some alternative ways of looking at how transmission of data and connection between peers happens that isn't put it on the public DHT or put encrypted data onto public networks. We need to be able to have a much more adaptable and configurable approach towards how what a network is and how it is constructed, how data is routed around it. So those are some of the things that we've done. Those are some of the things we've learned. And sorry if I went a little over time. Happy to answer any questions async in the chat if we need to keep going. We're working backwards. Woo! Can you expand on what you mean by new vision of native IPFS? question from Mash. I think when we think about native IPFS support today, it often means Go IPFS. It means something that's connected, like it's unspoken, but it means something that's connected to the DHC. It means something that has a bunch of peers aggregated. It's persistently connected. It's dialable. Things that are not dialable. A good example of things that we really can't consider natively supporting IPFS. But I do think that at the network layer, things that are only HTTP connected at some point should be able to be considered native IPFS in some way or other. And I think there's a lot of ways to do that, and we're talking about that in the Gateway API conversations and things like that. But it is still TBD what that looks like. So I think when I say native, I mean pretty much like what is native support? What would native support be considered as? The browsers are HTTP clients, but they're not servers. They're native implementations of HTTP client. Do you have to be providing data to be native in IPFS? I think there's a lot of questions around what it actually means. Yeah, I wasn't throwing shade at Russ. All right, we can move on. I'll look at any questions in the chat.
And now, I think this is a perfect way to transition, because what I'm going to do next up is our panel. So actually, and Dietrich, you're on that panel. So if you can keep your video sharing on, I'm going to add myself to this list of spotlighted folks, and then I'm going to bring our other two panelists in, who are Boris from Fission and Adine, who is the lead maintainer of Go IPFS. And so it's not a workshop if it's just people talking all the time, which I think is a great comment, and we need to. And so for this portion, we're gonna spend roughly half an hour. I'm gonna set a timer, talking about some of the things that we've learned today. I'm gonna try and step back and take a bit of the position of facilitator, or whatever you call it, the person who just says, interesting, here's a question. And we'll hopefully hear from Adine, Boris, and Dietrich a bunch. I think we're going to start with Boris, if you don't mind, just as a way of kicking this off. And Boris, you can take this question wherever you like. I'm going to monitor chat, so if people have any questions, pop them in. We'll try and bring them in. And panelists, feel free if you want to tack on to anything someone's saying. This can be conversational. But I think that one of the interesting themes that seems to be coming up in a few places here is spanning the gap of IPFS as a mental model, which feels like both like a macro and a micro thing. Mauve and Agricore, they were sort of talking a bunch about how just abstracting over multiple P2P technologies can make it easier to sort of just get people over that hump. Carson, make it easier for people to fail faster. This idea that, hey, can we have more people come and iterate, make their way over, see what works, see what doesn't. And then Dietrich, this comment, don't go full IPFS and introduce people slowly, I think was a pretty phenomenal strategy for actually crossing this divide. Boris, flipping it to you, what do you think? How is that the right way to interpret some of what we've been hearing? How would you take that from there?
So lots of things resonated all throughout this. So what Fission is doing is trying to put a full application model on top of IPFS. And we thought we could focus on that. And then we slipped down the slope that Carson had to slip down. And we found ourselves having to invent a decentralized auth protocol. Good news, much like the Web 2 days, when we had to invent OAuth because it turned out that putting passwords into arbitrary third-party clients, or having to figure out how to extract an IPFS node key and put it things, actually has generated lots of stuff. And in fact, we've gotten lots of adoptions around that. And it's going lots of interesting places with UCAN. Carson also called out to the thing that I'm going to write a post that says IPFS has won. The ... here is kind of like, oh shit, now we have a lot of work to do. And I think a lot of the other things in here, what has won is content addressing and hashes and the concept of self-verifying data. And even that mental model is just kind of barely there. How you get to it, the vast majority of people fetch these things through IPFS gateways. The vast majority of people fetch them through IPFS.io as a gateway. And we can see that some of those, what some of those problems are. Without Fission attempting to build an entire application model on top of IPFS, we don't get to some of these other things. We start hitting issues with Go IPFS. We think we're dumb, and we're like, hopefully someone else is smart. We finally, it takes us 9 months to find the right people, Cake and Y. And they're like, oh, actually, we can introduce you to all the right people. And we start meeting with other IPFS implementers, and we realize everyone has the same problems. And that in some ways, a central IPFS.io has been papering over some of these things for a while. And yeah, so I think there's a lot of stretch around a lot of these things. But now, I mean, one thing that hasn't come up that I want to focus on is in fact some of the tensions of having a large entity building a lot of things versus a model where more things are actually pushed out in different ways. And a large entity can do things like do convening, do an IPFS camp, have specs where everyone gathers and talks about their use cases together and then goes off to their implementations. I've spent a lot of time in the Ethereum community. Some of the things that were mentioned earlier are incorrect and have in fact failed. There aren't a lot of Ethereum node implementations. Like there are, but only one is fully funded with infinite runway by the Ethereum Foundation. This has been fixed with ETH2 clients in interesting ways, and there's an argument to be made that some of the really hard parts, and I'd look at something like IPFS mobile libraries. We should not build those more than once. Go mobile is probably the base for that. Really hardcore, low-level performant libraries that actually tackle the challenges on mobile that get built once. So that's an example where it's like, no, we shouldn't have multiple implementation because that's really hard. That's the Lego piece, the smooth plane wing that needs to be shaped and tuned for a specific use case. Whereas many other layers, like a general SID library, there should be a bazillion implementations of that because that's the layer that has fully won and is quite easy to read and write in different ways. So I'd say that we need to keep picking and choosing that, convene, have a more open tent, migrate some things out of individuals' orgs into more of community style things, and then look for models to actually just adopt more people in. We want more people at the table. We want to know, don't worry, we're like all learning together. That's my opener.
More people. I agree. I think that's one of the TLDR of everything that I just talked about was like, hey, look at all the different people. There's all these different groups that we work with. And a lot of this is us going to those groups and we rock up with a single implementation. It's designed with a specific set of assumptions and a single operating environment, single set of requirements. And it's even though it seems flexible and it seems like a toolkit for building P applications, it ends up being a pretty big barrier. I think more diversity in our ecosystem is going to make it stronger and really increase, I think, like the vector of choice there. And I think choosability is one of the things. Like, I think what Boris, it's really nuanced, right? Like we want a lot of choice, but not too much choice. And that's really hard balance to strike. And we've seen that in the web platform choices. We've seen that in JavaScript world for sure, where the explosion of choice has led to incredible
Somebody call me when the Butler Wars are over.
Right. Like so it's really hard balance to strike. But I think when you're talking about deep platform integration, like something like native iOS support or native Android support, for sure. But yeah, I think doing that once and letting people wrap it in the way that it works with a high level abstraction, great. One of the things that for me that I think, and I'd love to hear from Adine on this, is really a question for you. A lot of what we're talking about is kind of like the veneer, like the furthest out abstractions on top of this protocol, not necessarily the core implementation. And I can talk about all the challenges that we've had with different groups and different people, and how hard it is to get IPFS into weird places. And you hear me all the time talking about this stuff. But a lot of the times, like the intractable part is actually that network layer and the architecture of the DHT, and how like when IPFS is working at its optimal, a whole bunch of things are happening that people, I think, take for granted and don't understand how it actually works. And I always end up coming and talking to you.
Yeah, I think, I don't know if this is the right way to phrase it, but to some degree, I think that we have talked for a long time about like IPFS more broadly, and it has been said repeatedly over a long time, like IPFS not equals, and I guess I'm giving away my whole talk, which comes after this, but like we've been, a lot of like IPFS not equals like IPFS public DHT does not equal BitSwap, does not equal TCP or Mplex or whatever, right? Does not equal those things. But for a variety of possible reasons, it still sort of sticks with people in that way because they don't have so much exposure to alternatives, I think, is one possible answer. Is it the only possible reason? No, but it's maybe one. An example of this is pure, like having authentication to some degree and for BitSwap. People have asked, how do we do this? And for a long time it was like, well, already in the protocol, you can do this based on peer IDs. We can change the protocol so you can make it do other things, but right now it works with peer IDs. And they'd be like, but like, there's no API in Go BitSwap, and Go IPFS doesn't have a flag that's like -- IPFS add -- for Brendan, right? There's no flag there, so like, does it work? And yet, like someone who joined like, the community put this thing together in like a week or so, because they just went and were like, it was like, oh yes, no, I believe you. I bet you if I go look in this part of the code base, I can go change it. And that's just an example of like, it's like there's like the mental blocks that happen even before the code blocks, even before the various gross code things that Carson mentioned and Hugo mentioned and etc. Like even before those, there's like mental blocks before you're willing to open a code editor and like see what's up. And hopefully, I think trying to promote more implementations and make this more like visible will help people get used to the fact that like it gets to look a little different. It doesn't all have to look the same way.
That's great. We have a question from the YouTube stream. Is it in the Kevin Mir Mohammed Sagedi asks, is it in the cards to have native Android and iOS libpbc implementations, something that we can import in React Native? This is a toughie. It's like specific technical question.
Well, actually, I think it's really like, this is exactly the question that we kind of get all the time. How can I have the IPFS thing that works with my stuff in my way? And the what native means, I think, is really like in the question that Manch asked earlier. What native means is really undefined. If it's functional, is that native enough? Oftentimes, though, and I think this is why why I was asking about the DHT specifically, like if it is reliant on some other external massive network that you don't control and can't connect directly to and be a first-class citizen of, how functional can it be? And I think that's where we're playing all the time, like pushing on these barriers. And Boris is nodding because just all the challenges they've had trying to get this stuff working as a web platform in like the global scope of a window, in one tab in a browser. So we're in so many ways we're pushing on the boundaries of how close can we get. What does it mean to be a first-class citizen of that network and have that implementation actually function? And so in React Native, yeah, sure. Yes, you can do it. But if it is not a first-class citizen of what the DHT, is unclear how native that actually is and how functional it's going to be.
So this is exactly it. So we need to be realistic and we have to be pragmatic about some of these things, about which parts of the IPFS has won we start prosecuting and where we make those trade-offs. So as an example, the very first thing that we should have is we have a great library for making local car files and uploading them to an HTTPS endpoint in classic RESTful style. You are unblocked from doing that today. There probably need to be some like basic SID and CAR libraries that are shareable. A CAR file being a way to bundle a bunch of SIDs together in sort of an offline way. And this, we want to keep the integrity of IPFS as self-authenticating data. Oh, I can trust it, right? It was here locally. I can push it. The fact that it used an HTTPS transport and used a server to do some other stuff. One of the things that my team is working on, something that I've been calling the append endpoint that will do some of this. You will upload a file, and it will do DAG surgery on the server to put it at a particular location in a directory. So Fission's approach, there's all sorts of other stuff that we have that is like baggage. So some of you have heard me rant about pinning before. Most people who run IPFS at scale turn off automatic pinning garbage because it's a garbage collection internal thing, and it has leaked all the way to end users. From our work with end users, what do they care about? They want my stuff to be online. And so we went ahead and designed a file system and have file system roots where my stuff. And so we are pinning, we are keeping a single IPFS hash around, but it represents the entire file system. So for Mauve's earlier thing of wanting to be able to like share stuff together, that's been on my hack list that I should write up publicly somewhere where ideally you can literally just put a little DNS link somewhere where boris.fission.name is something that Mauve could put in this little file, and all of that SID would just like stick around. That's a lot of stuff we're stacking on top of things, and it has zero to do with the DHT. If we want mobile clients to participate and participate broadly and trust that these hashes are awesome, and that if even one person cares about keeping them around, even if IPFS goes around, my mission is to have every human on the planet to be able to put stuff online effectively for free forever. It will be ugly, it'll be a hash, it won't be a rented DNS name, it won't support IPNS, but at the very least, we can keep human data around in perpetuity if even one person cares, or keeps it on a USB key and plugs it in the future. And that's where a lot of us who are working on a bunch of other things, of all the other exciting things that IPFS does, need to dial back our stuff and be like, can I put a file on IPFS and get a hash back in all the places that I want?
I think that's a really great jump off point. And because as we've been talking about this sort of, makes me think about the intersections between clients and like and the spectrum of sort of thickness, right? We talked about a thin client, a thick client, server, something in my mind, Boris, something that can just hash and create a CAR file that is content addressed is in many ways, I see that as the foundation of a thin client sort of origin. And then participation in the DHT, this question of citizenship, like is your capability to be first class is like a thickening process. But I think on another axis, we have this question of like, what is the difference between an application and an implementation of IPFS? And I'd like to put that to this group. Like, do we see a distinction there? Is that a healthy question? Dietrich, you're talking about this question of like, we don't. HTTP doesn't have like an application platform. But then Dean, when we were talking about sort of documenting the number of different implementations of IPFS, there are a number of projects listed on there that in my mind sort of might actually be classified as applications, right? And so I'm wondering if that's a healthy distinction, what is the difference, and where others would draw the distinction, if they would.
Yeah, I guess there's probably a distinction to be drawn, but I don't know if that's where I would put like the thing that needs to happen to some extent, which is, and again, more giving away of things for the next talk, but like if I'm just doing content addressing, right, and I don't really care where the data arrives from because I can verify it, my application is going to should have lots of interesting ways in which to get the data. And maybe they'll have some standard ones, and maybe there'll be some ones that are specific to me. I have an application. My application has like, I have a social graph with like a few people, and I'm going to start checking with them, or we've agreed for something. Like there are all these extra mechanisms that are going to come in that you know, an IPFS implementation doesn't have to care about, right? You could just be, I'm just going to use public DHT. I don't care that Brendan probably has my stuff and he's my friend. Nope. Or you can decide to like leak it in and be like, oh, actually, my application can choose to do extra things with the IPFS components because like I know more, I know better, right? The people who built some of the library tools gave me some tools to work with, but like I know what's best for my users. I know what I want for them. And so I think like, you know, maybe you could decide like there are library components that are implementation-y and that you can start to compose them. But like at the end of the day, all of these things should be, configurable to what the application developer needs. And they're going to be deciding what the IPFS stuff looks like.
So, and again, the word app here is overloaded into many, many different ways, right? Another one of my missions is to kill the LAMP stack because it is naturally centralizing. So part of the, and it shouldn't just be that we like take the A out and replace it with I, the limp stack. Oh my God, that's so terrible. Because as Dietrich said, we have new components, so we can think about this differently. I think there are some DX goals, right? So I would like, again, I'm very much so this is some of the stuff that we're driving towards is like, when I say any human should be put a file on IPFS and like keep it there forever. Every human should be able to publish an app in like sort of running on the web engine. Let's put it that way. In a similar way. So I'd like some protocol and implementation pieces, right? We have IPFS 404, and then we realized, oh well, we actually need SPA support just like Netlify or Vercel does. So we put someone on putting a PR into Go IPFS, which we are supporting as the main implementation that's out there today because we don't have the resources to replace all this ourselves, and we want to make it portable at the protocol level. So working on spec level stuff to say, hey, let's put redirects in to the protocol directly. Again, that crosses over. In reality, we could have solved that at the Nginx layer. People who run IPFS in production, most of them run Nginx in front of it. So this is an application architecture of some of these things that goes all the way to ops and how you put this together. We could solve it at a non-spec, non-protocol at the Nginx layer. And then immediately, if someone accesses that IPFS app stack somewhere else, because that's the beauty of content addressing, it will break and not work because it's not in the protocol. And so we need to be realistic about both those things. You know what? You need to put these things together to robustly run things in production. And also, there are some things that we should put in. And all of these things have to be displayed in such a way that isn't like our experience coming in. We basically like tripped on all the same foot guns that everybody else did. But because mostly there's just one big IPFS.io like team that runs it with a specific needs, we had to learn some of that from scratch. So I think there's all these things at all of these different layers that we actually need to push the boundaries of have people figure some of these out and give them the tools so that they can figure out what's specific for their application stack needs at various layers.
There's a bit I removed from one of my slides that the backwards compatibility is the best thing with HTTP, is the best thing we ever did for adoption. And it's also the biggest possible trap and one of the biggest barriers towards people actually learning IPFS and figuring out how to deploy it, build on top of it. One challenge, I think, both Boris, you and Nadine have talked about kind of like protocol configurability and extensibility. And one thing that IPFS does that I think is really interesting is that we have really strict layers, really strict layer adherence between the protocol layer, the network layer, the protocol layer, and the application layer. You really build on top of IPFS. It's very rare that you see somebody actually kind of reconfiguring the protocol to do different things. And I think with HTTP, we think that that's actually happening as well, but HTTP headers actually, like almost the entirety of the extensibility of what we consider the web application environment is actually just the extensibility of the headers for HTTP. And so a lot of what we consider application layer logic is deeply embedded in every single message the protocol sends. And that is, I feel like without acknowledging how tightly integrated the HTTP application stack is, it's really unfair to say that we have that level of extensibility with IPFS, because we actually don't. Like, there's not really a way to do that with IPFS today.
I mean, and the depths are so dark here or not dark, but deep in this. We we need to do this same talk about IPLD, and people are like, "Did you deploy a planet scale structured database when no one was looking?" And so my team is thinking about some things like autocodecs and putting WASM in there and adding a VM to IPFS. What? And so I think this is the challenge, is that we should really be pushing people to not go like, don't LARP HTTPD, but with IPFS. Right? Really understand what we're using it for and what's really valuable, including being like, you know what? No, you should just do a REST API and some sweet HTTP, right? Like, that's like, you don't need, it's the same sort of thing of like, should we sprinkle a blockchain on it? It's like, a lot of the time, no, including the fact that IPFS has many of the same properties that a lot of people look only for blockchains to. Oh, you've got Merkle trees and you've got these structures and it's immutable and it's self-verifying but people are then looking for, where are the accounts? Where are the end user accounts? And so we're stuck actually between these two things. We shouldn't LARP as HTTP, and we should probably say that a lot of the things that people want blockchains for are actually provided by IPFS. Yeah, that's a lot of different layers and audiences to serve.
But I think that's a really interesting point, because while we're talking about don't LARP HTTP, we're also talking about like, wow, look how far you can get on just kind of generic metadata, right? Like the headers. And Adine, we've been talking a little bit about in the IPFS implementers working group on the IPFS Discord, which you should join in the middle of a panel discussion. Hopefully this is showing up on your YouTube feed, sure. But metadata conversations are starting to surface, right? The idea of attaching tokens to BitSwap as an example. And I think that story feels like we're just starting to crest into that as we sort of have these conversations about building and advancing the protocol. To me, that strikes me as a really interesting point. Like, we haven't actually formalized a conversation about like, hey, how do you do metadata stuff? And like, as someone who built an application on top of IPFS and used it as a library, Go IPFS as a library before we were supposed to use it as a library, we did a lot of like construction of what might have fit into a metadata layer as a custom lib P2P protocol, because that felt cool and really like to be blunt about it. But I guess I should try and turn this into a question. And I guess my question really is like, when we talk about let's not LARP HTTP, the upside of IPFS is looking at some of the internet stack sideways. How do we keep some of that magic and still provide some of the like easy scalability that comes from just like headers?
So I'm gonna answer part of the question and then sort of answer something that's a little bit related to some stuff that came from the last one. I think this idea of like, how does configurability look like in IPFS world is sort of interesting. We'll call it like doing like authentication and stuff that allows you to sort of pass, so like, oh, here's the reason why you should give me data. It looks a little bit like headers, a little bit of that feeling. Areas where it gets like a little more complicated are, I've decided that like, ATP, the Adine transport protocol, is the best protocol and is the only one that my implementation will support. And it turns out that that's, I don't speak TCP or Quick and can't really talk to anybody else. And so data from, people who use my implementation may not be usable from data, from people who use your implementation. and then maybe somebody decides to build a bridge where they like vacuum up all the data and they like sort of bridge it over or something. And how we help people like navigate what that means when you get to like change things so substantially like that, where you can sort of, because IPFS does work in offline environments, you can create segmented networks that don't talk to each other. And in the same way that like Boris was mentioning, oh, like IPFS.io like papers over all. To some extent, one of the ways in which it does this is it's like, oh, if it loads on IPFS.io, like that's probably IPFS-y enough for me, right? And maybe that means it's advertised in the DHT, or maybe it means that the folks who run the IPFS.io infra peered with some other companies that didn't advertise all their data into the DHT, and so yeah, that counts good enough too, right? And figuring out how we want to, yeah, I guess both empower differentiation and allow people to build different versions of this, but also help people figure out like what's going on and how the pieces do and don't fit together is useful. Maybe that looks a little bit like the crazy, like, can I use it for JavaScript, where you can find out which browsers implement which wacky new JavaScript things today. Or maybe it's other sorts of tooling, but I think that's part of it.
I think it absolutely is. And I think the other half of this is us. So this is some of the stuff of coming together as a community. So if you say, can I use this? What you're actually saying is you're saying a centralized area where we all come together and we do some interop testing and we work stuff together. And we're like, no, okay, we're going to get IPFS.io to support redirects and Cloudflare to support redirects and Pinata to support redirects, whatever the number is. And we're going to say, let's do that. There's other questions about which implementations might have redirect support turned on by default or other things like that, right? And I think those are where we can make some quantum leaps in various things. And those are some of the things that we can put together as pushes as a community while leaving the door open. Absolutely. Like, hey, I wrote this custom gateway that does blah, right? So I posted some links earlier because we run a lot of, we put our file system layer on top of IPFS. The standard gateway, we use DAG links to point back to previous versions and have this neat structure that is enabled by IPFS and IPLD that is amazing. The standard gateway thinks that I have 1.4 petabytes in my file system because it doesn't know the way that it just like adds all the symlinks together, basically, right? And that's one of those things where I'm like, yeah, I don't really expect the standard gateway to, like I should put this somewhere and see if anyone else has this pain around symlinks that we should get around to prioritizing fixing that. And I think that's a really great question. What is the user expectation of like a raw IPFS gateway browser? So that becomes, you get that delight and discoverability, right? And in some ways, again, it's going back to, and we saw a screenshot from Jeropo of the like Apache default directory browser kind of thing. And I think the flip side of that is, then how do we again show that there's more than HTTP here? There's more than files. What are the standards when you look at like a BitTorrent file? I don't know. Maybe we do like a crazy visualization that shows that it's everywhere, or right? Like we do want more people to think about content addressing and do that. And we need to, in some ways, as a larger community of IPFS aligned and interested people, make some strong goals of what we're going to work on together, and then commit to doing it. And it can't be any one org driving that.
That is the stopping point. Claps. Came in at half an hour. Forrest, you brought it home perfectly. Thank you so much to our esteemed panelists, Adine, Dietrich, and Boris. This is a quick experiment. If you like this, great. Hopefully we'll see you on other mediums. But in the meantime, I think we are now going to take a 10-minute break. And at the top of the hour, we're going to come back and listen to the parts of Adine's talk that he hasn't been forced to dox in this conversation before. Adine, we'll do you a solid if we do this again, where we won't make you join a panel before you give a talk. But we're learning. We're learning.
Okay, I
yeah,
get more
thanks.
time. I get more time to talk about other things then.
Exactly. You take some questions and we can focus on just trolling you in chat. But this is great. Thank you very much, everybody. So I'm going to share screen now. We'll take a 10-minute break and we'll see you at the top of the hour. Can you hear me now?
We heard you briefly.
Can you guys hear me? It may not matter if
Yep,
Brennan's audio is working. Maybe I just go ahead.
do it.
All right. Cool. All right. Hi, everybody. This may be a little late in the day for this, but this is a call for new IPFS implementations. So about me, my name is Athena. I am a fan of IPFS. I've been working on it for about 3.5 years, and I am one of the Go IPFS maintainers. A little bit about Go IPFS. It's the earliest implementation of IPFS. I think the first commit was in about 2014. It is the most used implementation of IPFS, and importantly, it is not exactly equal to what IPFS, the protocol, is. Other things that are not IPFS include IPFS.io or its sibling dweb.link, things that support Bitswap and the IPFS public DHT, things that only support Bitswap, things that support TCP. These are things that are not exactly equal to IPFS. So what is IPFS? I'm not saying. I think the boundaries of what it means to be an IPFS implementation are a little fuzzy, and something that, like, as a community with many stakeholders and what IPFS is an area that we can sort of define boundaries with together. It's not like, oh, Go IPFS does X, therefore Athena is a maintainer of Go IPFS and says this is what IPFS is, right? That feels like we're back to Go IPFS is not IPFS. It is content addressing. That's certainly part of it. Some areas you may want to think about of, like, is this pushing it? Is BitTorrent clients can use info hashes to download data. So are they IPFS implementations? If not, why not? If I put the magic incantation below, which for those not fluent in multi-formats, means I am a BitTorrent file that is CIDV1 with a SHA-1 that is 160 bits long. Is that enough? If not, what else do we need? I feel like there's some area to explore there. There's already a bunch of IPFS implementations, so this isn't news. There's about 15 on this list that some folks compiled in the lead up to this meeting. You can click there. The link for this is hackmd/@adin /more IPFS with an A, because that's what we're looking for here. So what's wrong with just having a single primary IPFS implementation? There's just a lot of use cases. We've been through this sort of already, and we've seen this through a number of the presentations so far today. Putting them all in one place hurts. It's hard to keep everybody, sort of everybody's thing happy. You're like, oh, I want to add in, can I have, IPFS daemon -- upside down? That only works for me, but I swear it's fine. It's fine. It's just a config flag. It's all I need, but it's going to be great. And it's hard to do that because it interferes with the various config flags that everybody else wants. And basically, it's sort of having this very wide you end up having this very wide interface of like this one implementation needs to solve all problems. So you have effectively the empty interface for what does Go IPFS do, which is not great. You don't get to move as fast as you could, like as Jeropo mentioned earlier today. Also, I wish it came this way when I got repo permissions, but becoming a Go IPFS maintainer does not mean that that you're perfect. You make mistakes. You make bets that maybe you shouldn't, and you don't make bets that maybe you should. And people should be able to make these sorts of bets, right? For what is the right way to do content routing? What is the right way to do data transfer? What's the right way to do mutability? We can try and make things pluggable. Some of the work that was done around DNS link and how we can sort of enable that to as an API to cover many different mutability systems is helpful. But sometimes you want to build things in, and deciding what to build in requires making a bet on some technology. And if we look around, right, there are many HTTP clients and servers, and even BitTorrent, which is not too dissimilar from us in a number of ways, also has many clients. So this is even within the peer-to-peer world, if you're going to sort of grow your adoption like this, having lots of clients seems like a reasonable thing to do. Yeah, so this is just more IPFS implementations, and some of these are, when I say small and big here, these aren't meant as like, oh, one of these is a better thing to do than another, but just the scope of like how much can change, right? Writing with a different language or for a different platform is one way to do this, right? How you want to change the structure of how the data lives, how you interact with the data. What sort of assumptions you can make about the data, right? These are all part of it. Elastic, the thing that Linux to IPFS, right, made assumptions about how you got to interact with the data that could make things faster and better for that use case, right? This is part of it. These things are important. But there's ways to change this that go further, that are like, I want new protocols. I want new protocols for content routing. I want new protocols for data transfer. I want new protocols for mutability. How do I do this? I may want networks that some are disjoint. I may want ways in which we can combine them. How do we want to do this? What are the right ways in which to combine to make networks that are slightly different compatible, right? I have a group that is offline in the woods, and then they come back to everybody else. How do we want that bridging to occur so that they can interact with each other in one way and then come back and interact with everybody else separately? So examples, Elastic IPFS is one example. The goal of this implementation was, I would like to serve data to other IPFS nodes and make it easy to work running it in like a commercial cloud environment. That's like the basic pitch. And they are doing this, right? This goes back. This is like, yeah, we are reworking things to do, have the databases and APIs that we need to make this work for us. But you could go a little broader. You could have an IPFS and BitTorrent server. So IPLD is pretty cool. Means we can basically represent any of the existing hash-linked data formats, which is almost everything in the peer-to-peer space has tried this, and some things not in the peer-to-peer space as well. So couldn't I just take a BitTorrent server and then plug in some pieces to like serve the data over BitSwap and advertise it to some content routing system, DHT indexer, a tracker, like a BitTorrent tracker? Wouldn't that also work? And that way I could sort of serve data to both networks without duplicating the data or anything like that, and it sort of works in similar ways. lets people utilize both sets of clients to fetch the data. You could flip this around and do it on the client side, which is people could just use info hashes as CIDs with the magic incantation from earlier, and build a network and build a client that can fetch from both, right? So this is pluggability, I think, as Carson mentioned, not just at the, and as Dietrich mentioned, not just at libp2p as equals network, pluggability, but yeah, sure, why not? Just swap in the BitTorrent protocol. That seems like another way you could fetch data that's based on a content address identifier. It only works for that one type of data and that one type of network, but why not? And more broadly, if we look at some of these content addressed systems, or if we look at systems that try and do like decentralized storage or sharing in some way, they're all using hashes. They're all using hashes underneath. And they tend to do my system, like they want like URLs that look like my system. They want like, for many like blockchain storage things, like blockchain storage : / my transaction ID. You're like, why? Why would you do this? Wouldn't you be happy to get that data from anywhere, not specifically like a transaction? But it's a content address. I could just make it a hash. I have a hash. I can put a codec in front of it. And now I know how to sort of work with the data here. And we can allow IPFS to be like a little broader in terms of the sets of data in which it encompasses, right? Make it easier to work with things that are not UnixFS. And we've already, there's already work going on there in terms of how this goes on with gateways and working with car files, and the great work folks have done on other codecs, whether it's like DAG-CBOR or DAG-Jose, and work with UCANs. So we're getting there, but there's room to keep moving forward. And experimenting with new protocols. You can show what is different, show why yours is better. And data transfer protocols alone, I have like a list of like 4 or so things that I want to exist that are not there right now. I want protocols that just transfer over manifests of CIDs. I want protocols that can handle transferring very large like SHA-2 and Blake-3 objects in verifiable ways. I want protocols that are optimized for things that are Merkle trees, but like not well suited to BitSwap or GraphSync because they're too narrow. They're too the blocks at the bottom are too small, right? Trying to move around things like Filecoin pieces. Like there's so many options here. Why are we restricted to just these two? More content routing systems. Really, just many. Like there's so many possibilities. People have ideas. People should be able to feel free to experiment with some of these. I think IPFS we're trying to help with some like pluggable APIs here, but that's just Go IPFS. Like take the libraries, rip them apart, use what you need. And then of course, like authentication and mutability, and I guess encryption is related in here too, where like there are very opinionated ways to do anything related to like protecting users in some way. Authentication, mutability, encryption. Mutability is a little different because it's about sometimes it's about identities, but there's opinionated ways to do this. There's not only going to be one best way. You should be able to try them out, and they shouldn't all be like it's not like IPFS. It's like something similar. It's like, no, these are IPFS implementations. You've just chosen to use a different protocol that if your thing works out well, other people start adopting because you had a good idea. And I guess maybe the corollary to that is there are no perfect implementations. It's not that you're not going to do it. People have different use cases is what this is all about. It's not, oh, if only Go IPFS did ABC, that would be the dream. There's many different ways to do this. Try it out. Maybe the architecture or your design will be good. Maybe not. and then it's okay, I'll try again. You know, a call out of this is like, WebAssembly is really cool. I like it. I have some experiments I've done with it. It doesn't solve all your problems. Saying, oh, if I wrote it in WebAssembly, that would solve all my problems. It could load other WebAssembly, and that would solve even more of my problems. But it is not the answer to everything, which sort of makes sense. Almost nothing is. Some things maybe we want to watch out for is build what works for you. This is good. But knowing being able to explain how it works and how it fits together with other implementations is part of this. They sort of mentioned in the last session, being able to describe to users and developers how it is that these different IPFS implementations and pieces fit together is important to not lead to user confusion, right? Help them understand why something has worked, why something doesn't work. Sometimes this can be confusing, like the model where we've switched to self-certified data where you can pull data from anywhere. It changes things. A story I kind of like to go to here is, you know, someone will say, you know, I tried to use, I ran Go IPFS on my laptop and I fetched some data and, you know, the speed was okay. But when I did it on my desktop, it was really fast. I think you guys should really figure out like your CPU usage and something, because it's just much better on desktops than it is on laptops. And you're like, well, that's not really what happened. What happened is you fetched it on your laptop from wherever it came from. And then your desktop fetched it from your laptop at like land speed, which was like really fast. And that's what happened there. And so some of these intuitions that people come from like the HTTP world of like, yep, I asked for the data, then you sent it back to me, and I can like keep reproducing that, right? It changes. And so making, you know, tooling, documentation, communication to make it easier for people to understand how the pieces fit together is, I think, part of this. So sum up, because I want to make sure we have room for questions and such. We need more implementations. We need people to experiment, build more things. Join the crew. We have an implementer sync every other week. Next one is on May 26th. And come say hi. Tell us what you're building. See what's going right, what's going wrong. See if you can find other people who want to work with you on solving those things that are going wrong. And say hi. Whether it's GitHub, Matrix, Discord, Slack, we have a lot of places where you can find us, but say hi. And now I want to look at any questions. I feel like I saw a lot of stuff going through in chat today. So let's see what we got. Oh, I guess, yes, also a call out. Go IPFS is getting renamed. So if you have an opinion on what the rename is, or you just want to troll some people with funny names, go to the Go IPFS repo and comment on the discussion there.
I actually don't think you need to rename it at all. Go IPFS is Go IPFS, and other people who create new implementations can pick their own names. It's not squatting on all Go implementations ever. It hasn't happened in Ethereum. It hasn't happened in other spaces. But I really do love the name Banana. So, you know, 2 columns there.
Okay. That's a fair comment to add too. Need for specs. Yeah, Brendan, there's a lot of comments there. If you could help me process them for which questions to go to next while I answer the specs question, that would be great. Talk about the need for specs. Yeah, specs are really important. They talk about what the thing is, and also if they're written properly, make it actually pretty easy to implement what it is you're trying to do. I think having multiple implementations pulling on it helps define the specs. and not just like some of the obvious ways where you're like, oh, can you tell me, like, is this business of how you do caching and HTTP headers for gateways, is that like part of the spec, or is that like an optional thing you get to do kind of way? But pushing it further to say, like, what types of things I'm going to be a member of the IPFS public DHT, which transport should I be enabling to be considered a good citizen? You know, unclear at the moment, like IPFS just like turns them all on. Now you're writing one in Rust and you're like, do I need quick? If I don't have quick, is that a problem? Is that okay? If I only do TCP, is it going to break the network if the Go IPFS nodes start turning off TCP? Right? These areas you get to like flush out as you go through the specs process and figure out what's necessary and what's like extra. Yeah, absolutely, Dietrich. If you have a thing and you're saying it's a protocol, you need some specs defining what they are. I think what's interesting, like the IPFS specs repo, as I think Dietrich mentioned earlier, not the paramount of specs. Very much work in progress needed, or work needed. And I think some folks here, as we've been talking in the implementers calls, have come up with some ways in which we can go about this. I think there have been some changes in how IPFS is considered over time. Like some things that ended up in the specs repo, which seemed sort of interesting or weird. I don't have all the historical context, but things like the repo layout for Go IPFS, because it used to match the repo layout for JS IPFS. And so it was specified so the two of them could share. And I think at some point someone realized, wait a minute, why is this the thing we've standardized on? Why have we standardized on like how we lay out our IPLD blocks at the file system layer? Does that make sense? Right? Similar with some of like the Go IPFS like HTTP API stuff, which was shared with JS IPFS. And it was like, wait a second, is this what we wanted to standardize on? And there's a few of those where it's like, you wrote the specs and now you're like, wait a minute, actually there's something more basic here that we're talking about, or maybe some of like the application, it's like some of the application model sorts of things. Like you might want to describe those, but maybe some of these things aren't things that should be spec. Maybe some of these are for the implementations to describe for themselves. Carson said that libp2p is the most important Lego piece. Do you agree with the statement? Should we think about making libp2p accessible everywhere, not full-blown IPFS? There are two big Lego pieces that go into IPFS. There's the IPLD Lego piece and the libp2p Lego piece. Which of these is more important depends on where you're coming from. I think libp2p has some very nice value in making it easier to like swap out pieces of the networking stack. I think finding ways to make libp2p more available makes a lot of sense. So I guess what's sort of funny, Dietrich says libp2p cannot be required in order to do IPFS. I think this is fair. I think this is correct. In the sense that, yeah, I just made a pitch for like an IPFS client that does BitTorrent things, right? The BitTorrent protocol is this UDP defined protocol. It has nothing to do with how libp2p operates today. There's probably some, Boris made a comment, oh, enter what is IPFS? But actually before you get there, you might enter some other questions like what is libp2p, right? In order to say, that libp2p isn't enough or needs to do more or whatever, like you have to say what that is. Would it be weird to back define like how to use HTTP as a libp2p connection? Maybe not. Would it be weird to back define how to use like, UDP BitTorrent protocol stuff and UTP as part of libp2p? Also maybe not. Hard to say. Yeah, so I think having libp2p available in more places, very cool. Is it the most important piece of IPFS? Probably not. Probably the most important piece for IPFS is like CIDs, content addressing. Because if the key thing, which then sort of turns a little bit into IPLD, because if it's like, if the concept of IPFS is that I can get the data from anywhere, then which networking protocol or stack I use matters less than the fact that I can get the data from anywhere. All right, see Dietrich, I want the oh, I think the repo spec being a bad thing is a good example. What other specs can we remove? So, all right, let's pull it up, guys. The almost anything related to everything with the word API in front, those should be removed. Anything that's about data stored on the file system, keychain, key store, removed. Repos removed. Then things start to look better. Now you're talking about addressing. Yeah, addressing, Merkle DAGs, MFS seems probably also removed. Well, don't worry, it's an empty file, so I don't have much to remove there. Yeah, those sorts of things I think can be removed. And in their place, put in other things like a, oh, I can stop screen sharing. Yeah, I'm done. In their place, we can put in other things. Like we have a libp2p spec for the DHT, but we don't have a IPFS spec that says this is what you need to be part of this particular public network, which is different than like what is the protocol messages for the DHT, right? It's like it's different pieces. Yeah. So sorry, not going to do GitHub removals live, but yeah, that's how it should go. My 2 cents. Is there a way of adding search using IPFS to a site using that service and a one-click upload and attach to IPNS for files? Searching through IPFS content is sort of interesting. People have come at this in a number of different ways. I mean, you're basically, to some degree, you need some crawler, right? That's going to look through content and index it and make it searchable. Some people have found ways to do this in semi-decentralized ways. Some of them just run centralized services that do your search for you. I think there's been more success doing this when you're following UnixFS data, because that looks like files. It looks like you can use a lot of the existing web crawling tools. I think this will probably mature a little more as people start to like build crawlers that are good at following hash links and like leveraging the linked data structure of all of this. I also think that there's some work that's gone on around the indexers, which is you should look up about that if you're interested, which will allow people to publish that, hey, I have some data, in a way that will make it more discoverable. Right now, it's sort of hard to be like, I want to learn about all the, like, how do I want to learn about data that somebody has? Being a DHT server that's not really what it's meant for. So there are other protocols for that people have started building, which I think will help with search. Also, for one-click IPNS things, I guess one thing I wanted to mention on top of was thinking about it during Mub's presentation was we actually can do delegated, like, call it like thin clients for IPNS publishing. That's like a thing you can like totally do. We even have like some nodes that are running they're preload nodes, which is a bad name for all the things that they're doing, but you can send them like an IPNS record and be like, yo, can you publish for me? And they'll do it pretty quickly for you, instead of requiring you to do all of like, fancy DHT machinery by yourself, which you might not want to do. And so I think there's definitely some good room to remove some of the long-term connection stuff, which is largely associated with DHT behavior, in replacement for like delegating that request out to another node as sort of like a light client kind of thing. And then you can like request out, figure out where you're getting your data from, resolve your IPNS records, whatever. And then you go connect to who you need, fetch your stuff, close down your streams, close up shop, and then back to transient land you go.
Fantastic. Thank you so much, Adine. This is lovely and super appreciated. I pretend my claps are the claps of hundreds of thousands of adoring fans. It's really, really great talk. Thank you very much. Next up, we have our last speaker of the day. Complete, just random flyby. I don't know where we found him. Some claim to have written the IPFS white paper originally or something. But from here, I think I will leave it to Juan. You can set yourself up. Juan, if you can share screen, we'll make sure you're able to do everything, and then we can get started.
Hey everyone, one second. Getting my all right. Can you see a blank screen with some mountains?
Yes.
Great, awesome. That's the screen I want to share. Great to see everyone. This has been a really awesome workshop. I've been super excited to see that we've basically converged on a lot of the same ideas across the ecosystem. And so huge kudos to just everyone here and many other people out there that kind of see where we are, see the gaps, see the needs, and so on, and we're kind of rallying to solve the problem. So my original intention when setting up this initial talk was to talk a lot about the same things that have been said in the talk already, which is great. I don't have to say those things anymore. Everybody else already said them. Maybe it's good to acknowledge them in terms of common knowledge. So what I thought instead to shift towards is to maybe talk about where to go from here, how to go from where we are now, point to a set of problems to solve across different kinds of implementations, walk through kind of a set of ideas of what may be viable, and then talk about how as a community we will make this happen. Meaning, I think there's a lot of interest here to fix a bunch of these problems, but not a lot of but the kind of trajectory or path from here to the future is a bit unclear. So what I'm gonna do is I'm gonna kind of suggest a bunch of ideas here, and kind of have this as a call to kind of think about these possibilities and think of writing these new types of implementations. And then I'm gonna kind of finish with a call to come together at IPFS Camp to then as a community make a bunch of decisions of where to go. Meaning, what should the protocol be and so on. That's like a community oriented thing that we got to get a lot of people in the room to start discussing and start doing the both the cleanup of past specs and cleanup of past system ideas to then kind of craft a new direction. So think of this entire workshop and the prior talks and this talk as surfacing a bunch of ideas of where to go, and kind of having a call to come together at IPFS Camp to work on them together. So let me maybe I kind of want to start with a story based on the web. And I'm going to be hopping around a few things here. And I want to also make it like very conversational. So if you have questions and so on, just drop them into the chat, and I'll help. And that'll help me guide me and so on. So when the web, as the web evolved, you can see here this chart that shows kind of the distribution of different websites using different types of servers. And you can see kind of, even by 1995, there were a few different implementations, Apache being one of the really key ones that kind of helped open up the landscape of and help a lot of people write new implementations. And then it took a while until we got like the later explosion of the web. And kind of what I mean by that is that it took a while to mix the client server model of HTTP with the computation that we know and love today in terms of these massive scale web services that can blend the HTTP protocol and the whole HTML, JS, CSS stack with pages and APIs and so on. And another way of like looking at the story is like this. In the beginning, there was kind of HTTPD, and a lot of people ran HTTPD. Then people started kind of like creating patches of HTTPD. So people started creating their own forks and their own versions, and started kind of writing different implementations. And it was kind of confusing which HTTPD version you were running, and so on. And then after that, people started crafting these different implementations and naming them something else, like Apache 2 and IIS and so on. And that naming change really helped everybody talk about what implementation they were actually running, and that there could be trade-offs between a lot of these implementations. And there are a number of other implementations that got written around this time that were super useful. Around the same time, people started blending computation in with HTTP, mostly through external means, mostly by using an HTTP server to then call out to some other process through CGI-bin and similar kind of systems. But then that kind of seeded the ground for a whole bunch of other frameworks and web tools that then fleshed out the explosion that came later. And that was when people stopped treating the web server as a thing kind of on its own. Of course, this is still how tons of web systems run at scale. But there's a huge transition when people started writing applications by embedding the HTTP server or client as a library in their application. And so things like the early Java work that kind of like accumulated a ton of like really good ideas to I think Whiskey and a bunch of other different kinds of interfaces that enabled translation of this sort of stuff, to then things like Django and PHP and many other frameworks and tools that enabled blending the computation along with the generation of the page, and that eventually ultimately leading to things like Flask and many other frameworks. There are probably hundreds of different tools, and things like Node eventually that kind of really took this to the extreme, where you were sort of composing the entire construction of the page and application at runtime. And that's really when the massive explosion of web adoption and web application development, I think, really happened. And going back to this graph, a lot of this adoption and so on has kind of gone down in terms of these big name servers. I don't know if this is what explains this gap in the graph, but my sense is that these days, the vast majority of web applications are running on systems like these, where you're embedding the HTTP client and server as a library in your application. So let's go think about IPFS for a moment. So in the beginning, there was sort of IPFS and JS IPFS, and the goal there was to kind of create this landscape where you could have kind of the larger scale distributions oriented implementation with Go and so on. And then you could have like a web native implementation that could just run directly in the browser. Over time, that led to a whole bunch of other different applications that embedded one or another of these pieces, or started taking some of these parts away. So things like Companion and Desktop and Go Mobile and IPFS Lite and so on, and a ton of other tools that have kind of either used parts of these implementations as a library or embedded one of them entirely or something like that. And kind of, but they were still sort of constrained by Go IPFS, JS IPFS, and the infamous like IPFS spec that is floating around. I think what's happened since then is that people have taken the really useful parts of the systems and sort of exploded out IPFS into a larger scale network of systems that's basically about IPLD data moving around some transport. It could be LPP, it could be just HTTP, it could be a bunch of other things. And really kind of starting to build applications on top of the IPLD data directly. And I think one of the key things that we need to do in this moment is to actually rename Go IPFS and JS IPFS. And I've been kind of pushing hard for this because right now people are still equating IPFS with the tool that you run in your command line that is called IPFS, that you install on your computer and it's called IPFS and so on. And so we're kind of being held back by the fact that we're at this stage and we still have the tool named IPFS. Like kind of the web sort of did away with that earlier. And I think we kind of have to do that so that we start recognizing all these other systems as full-on implementations of IPFS and full-on like systems that have their own trade-offs and their own design decisions and so on, but that can really like kind of treat all of these different kinds of implementations as first class. And when people are thinking about what IPFS should do or how to reason about content in IPFS and so on, the question becomes a lot more nuanced depending on the specific implementation, the specific service, or the specific deployment that you're talking about. And so I think like one of the big shifts that we have to do is like open up the landscape of implementation and just make it like much easier for everybody to kind of treat all of these other systems as full-on IPFS implementations. And they might not all interrupt. And that's one of the hard questions that we're going to have to figure out, hopefully at IPFS Camp soon, is like how to reason about data moving between all these different kinds of implementations. In many cases, it'll be difficult for some of these systems to interact. We've had a lot of this happening in the Falcon network, which is one of the largest IPFS deployments, where different tools and so on don't actually speak to each other yet. And so it's difficult to move around the data and whatnot. But I think one of the big wins that we've seen over the last few months and a couple of years, I guess, is a lot of services just moving around data directly through car files, through other formats, and learning to kind of read and write directly to those kind of intermediate bundles, and then building IPFS systems out of that. Now, I think like what's going to generate the big explosion here, and what we're sort of like kind of like about to encounter, is IPFS and WASM. And there's one, like, I have many regrets in life. One of them, which is a really big one, is that early in the IPFS paper, way back when I was writing it, I was strongly considering putting V8 directly into IPFS and just shipping IPFS the first version natively with a VM. And I was worried about the security implications very naturally. But I think in retrospect, that was a mistake. I think that if IPFS and V8 had shipped together from the get-go, kind of what did, the whole kind of history here would have been very different because IPLD and all the data structures would have just been written directly and run on V8 naturally. But anyway, I think the big thing that's going to open things up here is that I think where we're headed is that IPFS is not going to be a single kind of like binary or tool that you run separately, or like you treat an IPFS implementation as a different system that you're going to run and so on. But really, it's a way of kind of programming your application and your system by using a lot of these components as libraries, and really push a lot of the complexity of the network stack and a lot of the protocols, so things like BitSwap and the transports and BitSwap GraphSync and many other transports, and a lot of the complexity of and power really of IPLD and the ADLs and so on into WASM. And so I think like the big one of the big things that I think is going to matter here is to get to a point where we can start embedding WASM programs with a lot of the different kinds of IPFS implementations. And so this is what I think where we're headed sort of this year. I think it would be great as a community to kind of talk about all this sort of stuff in IPFS Camp. Now, I want to kind of like touch on a few things that I think are going to be really important to people writing IPFS implementations today and people potentially starting new ones, because there's a lot of people today. We've heard about tons of different implementations, which is super. A, we should kind of like support all those groups, and B, we should help make it way easier to do all of that work and all of that development. And so we should kind of like, I think it would be great if at IPFS Camp we can, or even before, we can look back and kind of like make problems easier by dismissing a lot of requirements or constraints to kind of like be a full-on, kind of IPFS implementation, or to have an IPFS deployment or an IPFS system. The kind of like litmus test that I've been using lately is like, hey, if you have a program that represents IPLD data with CIDs and so on, and it just moves it around with Netcat to some other program somewhere else, like, is that an IPFS system? And I think it probably is. I think that there's one key constraint here that I think our community is going to have to figure out, and I have a strong opinion on this, but I don't really have a good answer. Is like whether or not content should be findable and routable, and that will really matter. I'll hop into kind of thinking about networks in a moment, and thinking about primitives and kind of what are the things that I think are going to stand the test of time. But before I get to that, in terms of making it easy, I think one of the key things that our community needs to do is to have a strong focus on optimizing performance. And one of the pieces here is like, if you look at large scale systems like the web that we use today, all browsers, all large scale deployments of complex software and so on, they have extensive testing frameworks. And here, one of the principles that all of that is based on is, at the end of the day, like you really get what you measure. And if you're not measuring something, you're not going to get a good signal, and you're not going to get the outcome that you're expecting. So in terms of like really building, kind of like leveling up the success of the implementations everywhere, we need to shift to a mode where we're learning from the best in class large scale distributed system communities, and get to a point where we can really optimize and measure the performance of all of these different kind of implementations, and get to a point where we can start optimizing all of them. And this is like a huge undertaking to kind of build the tooling and the structures to be able to support this. We already have a lot of this kind of stuff in the past. Like we built out things like TestGround. TestGround it really enables a lot of this kind of testing, and tons of improvements have come out of this. We've done a lot of R&D to find problems and kind of turn it into like measurable outcomes, kind of fix problems. Like there's a really great talk from ProBlab talking about a bunch of different questions in IPFS to kind of solve problems and whatnot. But I think basically like we have to level up the community-oriented infrastructure to get to something like this, where like it's super easy to write performance-oriented benchmarks that then can you can kind of tie to an implementation, and you can see the changes that you're going to make and how they're going to ripple through kind of like all our users. And I think because we're lacking something like this, a lot of problems sneak in, and it's difficult to kind of evolve the software. When you think about systems like most of the programming languages that we use, or browsers and so on, we have cases of thousands or tens of thousands of people working daily on improving those systems. And the only way that you can manage a software system at that scale and keep good performance, don't break the things that matter and so on, is by getting to this kind of super robust performance and optimization structure. So one of the big things that I think as a community we need to do is to get to this kind of point where we have this kind of large scale testing and tooling. And so this is like a key component. I want to kind of like talk for a moment about like important primitives. So I think something that I think has stood the test of time like really well is CIDs. I think they've turned out to be really useful in a ton of ways. I've seen them even absorbed into systems that don't use IPLD or any fully, and so by nature they're sort of like bringing in IPLD. But the point is like they have turned out to be like a pretty useful component and primitive. And so tools that kind of use CIDs I think will very much stand the test of time. I think right now today, we all understand the power and utility of being able to manipulate these DAGs directly. But today, it's still like very difficult to write your own data structures. And it's very difficult to kind of evolve them and make them work across systems. And a big part of that is that we don't have a good language for expressing these in a language and runtime independent way. So for example, if you write some complex data structure, you have to go and implement it in a bunch of different languages for it to be used, or you're gonna have to like have a bunch of systems that don't know how to deal with it opaquely, and it can't like do translation in the gateway or anything like that. So I think one of the key things here is to shift to a mode where we can properly program all of these kinds of data structures in a way that all IPFS capable systems can interpret. And I think that one of the key to that is IPOB. The key to that is WASM, is bringing in WASM into the equation to then be able to have link all of the codecs and so on to be able to kind of interpret all of these data structures. I think another really great thing that's just kind of like helped ease the problem is car files, and they've all evolved quite a bit, and I think they're going to continue evolving. But just this idea that you can like take a bunch of data, bundle it into a car file, and then move that around has just been super useful. And so I would expect to see a lot more implementations over time just using car files directly. And this is a pretty good format to bet on because of its kind of like broad flexibility. You can think of having implementations that don't have a repo, they just kind of like point to a car file, or they point to some other tool written around or on top of multiple car files and whatnot. This also is what's going to enable kind of swapping whole libraries of content in and out and being able to kind of move them around. So if you kind of write a bunch of car files into a drive somewhere, you can like take that drive out and move it somewhere else. So I think like this is it's a pretty good format to bet on, and especially because there's like good thought put into the upgrades to this format. So as more and more features emerge, so like the new car V2 and car V3 and so on that might come down the pipeline, they're built with very much backwards compatibility in mind, so that you can kind of reason about them. One of the things I think is key for folks to remember is that there's, and I need kind of like a much better diagram of this because this is like super outdated. This is from like many years ago. Is that the broader IPFS network is a very large scale thing spanning the internet and potentially disconnected. So you have many different kinds of systems loading and using data in disconnected environments that may or may not be using the DHT, may or may not be using the new network indexers, and the content may not be like directly routable or findable. But you want to be able to like write tools and systems to be able to move around a lot of this data across these kinds of networks. So kind of like have this picture in mind where if your tool is putting in an assumption that some service is going to be around, then maybe it only works in a subset of the network. One thing I want to touch on is just kind of a sense of scale of where we are now and sort of like where we're headed. I remember probably 3 years ago, there was a large effort around package managers and putting in a lot of data for package managers using GoIPFS and so on. And at the time, we were having trouble with 1 terabyte of content, and just loading 1 single terabyte into GoIPFS or dealing with like a repo of that size was kind of difficult, and it's kind of complex to deal with like that kind of sets of static assets and whatnot. And today, like we are just kind of like in a totally different world. Let me show you like a thing to get a sense of scale. So one of the largest IPFS deployments is the Paco network, and just as a sense, like the Paco network is onboarding I guess today it's
there's like, I think about 80 petabytes of data total. It's like this insane level of scale compared to where we were 2 years ago or 3 years ago. And so I would encourage people to like write implementations and tools that are going to be able to deal with this kind of scale, with this kind of like magnitude of data. And this is like really stressing a lot of our assumptions about systems. So for example, just how we think about absorbing some large scale data set that's maybe stored in a ton of drives. And then we have to process it to turn it all into IPLD data. And that right now today requires like reading all that data, copying it, and splitting it up into a number of car files, all with these different like little graphs. And we can't really like have a way of kind of mapping onto the drive as it is now, and kind of being able to sort of like ingest the drive and construct like a set of companion indices or something that can point to the data. Like we're dealing with a scale of like of data ingestion now, where it is really questioning a lot of the assumptions that a lot of the IPFS tooling built over the last 3-4 years kind of had. And so I think like use this as a like massive opportunity to say, hey, could we like rethink how data onboarding into a content address network should work? Like, could we do a thing where like you can run you can take a drive with like terabytes worth of stuff, and remember that like the storage density is gonna keep increasing. Like we have like I think 8-10 terabyte drives now, 16 terabyte drives. It's gonna push into 20 and more in the future. And so a lot of the data in the world is gonna be like already stored in a specific set of formats. Can we lean into that and write tools that can just index the data on the drive as they are on whatever native file system format that drive is in, and then add a content addressing layer on top of it. So you can just kind of use the drive as it is, and just plug it into a set of IPFS nodes or IPFS systems that can like read that data and use that data. So I think like some implementations looking at this problem scale and being able to tune their tooling for this, I think will be super helpful. One of the things that this brings up is that all of that data right now, a lot of it is just standard UnixFS data imported into the network. It's not kind of like IPLD-fied in any kind of special way. Some of it is, but most of it is not. And that means like there's probably some other ways of importing this data or making it broadly usable that really go into kind of how should you import this? Or instead of importing, in that moment of importing, how do you create handles for that data already at rest in some structure and provide another secondary index over it? Like you could create a bunch of intermediate set of nodes and so on that point to existing data as it is, stored as it is, and then give you a different handle and way of accessing it, right? So you could have a lot of stuff added already as standard Unix files, UnixFS files in a UnixFS DAG, and you can construct another DAG that points to the objects in that DAG and interprets it differently. And one of the key things that enables that is all the IPLD data layouts and so on. But again, for that, we're going to need to make the entire thing programmable. And so we're going to need WASM, WASM everywhere. So yeah, I think I'm reaching the end of the talk. So I want to kind of finish up talking about like two things. One is what we're talking about here today through pointing out different possibilities and different implementations and so on is a huge amount of work. And part of that requires helping create and build and support a lot of these implementations. So one of the things that I've been talking to a number of people about is actually creating a fund to support people writing new IPFS implementations. So one of the things that I'm working on with some folks is creating a set of like a large scale funder of a bunch of different implementations. And I hope to have more news about this in the weeks leading up to IPFS Camp. But the goal would be to kind of like be able to support a number of teams writing different kinds of IPFS implementations and different kinds of IPFS tooling to then go and tackle a lot of these large scale problems. So that's one of the things there is trying to kind of leverage a lot of the community-oriented funding structures that have emerged in the Web3 community to then allocate funding to teams building a bunch of this tooling in a lot of these implementations, without kind of like inserting a whole other talk in this one about kind of like what's been going on there. I'll just kind of like leave it at that and say more maybe at IPFS Camp. The second thing is about IPFS Camp. I think a lot of us kind of like see the need for this happening relatively soon. And I think we're kind of now at the point where we have a very large scale community that kind of wants this to happen soon. Kind of like the original kind of a goal for this was to kind of bring together a subset of the community in July. There's all kinds of like requirements and so on that are shifting that over to September. So as I said on chat, I think it would be great to get input from the people in this room, because kind of what we want to do is like gather together the set of people that are here now to talk about this. So I would love to kind of like, so if you're here in this call, just kind of, if you want to get together and talk about all of this sort of stuff soon, like in kind of like a July timeframe, let me know here on chat, and that'll be useful. Like if you can sort of commit to come together and like go do this, like this would be really useful data for me. And separate, if you want to kind of, hey, no, actually, it would be much better for us to kind of push out to September and kind of like work towards that and work towards like having that a much larger community gathering at that point. Also, let me know that. So like just quick poll to the people hearing this. What do you feel the same kind of urgency that a lot of the people in this call have to get together, define a lot of these things, and kind of do this work sooner? Or would now, having heard this and having digested this, want more time to kind of reason about it more, and then kind of do a much larger thing with a much larger community in later on in the year? So just say it now in your on chat. I think it'll be very useful. Cool. I'm hearing a few things. Why not both? Cool. So we'll probably have some kind of thing like that. But that's useful to hear the feedback. Great. I think with that, I'm going to conclude and say, see you there. Happy to take some questions about anything. And since content routing is a big topic that I think was mentioned a few times already, but there's no like good. There's a lot of questions on how to do content routing safely. I want to plug the work that Will and others are doing on thinking about large-scale content routing in a privacy-preserving way, and stay tuned for a lot more thoughts on that coming out in like the next few months. I think that now that we've got a handle on large-scale data distribution, or like we're getting a handle on it, and we're reasoning about how to do high-performance content routing. Now's the time to kind of, or this year and next year, I think is the time to really put in place like the path towards privacy preserving content routing, because that's a really critical component that the networks right now don't do. But cool, happy to answer any questions about anything. And thanks everybody for like a really awesome summit with a ton of like really useful insights and thoughts and so on. There's a question about, is the vac.dev work relevant to privacy preserving routing? Yeah, I think so. If I remember correctly, it is pretty relevant to it. There's a lot of different groups that have been trying to work on this problem for many decades, actually. Like the cryptography community has been working on this problem of how do you do safe propagation of messages in the presence of extremely sophisticated adversaries for a long time. And there are a number of projects working on it. I think very practically, what we have to solve right now is how do you do efficient and low latency routing of about 10 to the 18 objects. So that's kind of the back of the envelope calculation of like roughly what you need to run something at the scale of Web 2 today. And in kind of like an O of 1 setting where you can do sub-second lookups. So you want privacy preserving sub-second lookups for 10 to the 18 objects. And that's roughly the shape of the content routing problem. I think if you can do that, you can do most applications that humans use on a day-to-day basis in a pretty good pattern. Also assuming that like once you do the first routing hop, you can then usually pull in vast quantities of the data that you need without having to go to the content router again. Like you have gotten the key bits of information as to where to find the content. You can now turn that into just single hop requests. And the good news there also is the cryptography community does have a ton of extremely useful protocols for how to do this. It's just a lot of them have been just theorized about, and they haven't really been implemented at large scale. So if you are interested in this problem, open up ePrint and just look for terms like oblivious routing or all the mixed nets work is relevant, all the ORAM problem stuff, and so on. So there's a lot of really good work that we can lean on that basically solves a lot of this problem. We just need really good implementations of it that are high performance and large scale. Yeah, that's right. ORAM, O-R-A-M. It stands for Oblivious Random Access Memory, so Oblivious RAM. Question about how do I think we should handle decision power on the what is IPFS question? I think this is like a traditional IETF sort of question, which is rough consensus and running code is what's going to carry the day with this kind of stuff. People are going to write things, people are going to call things one thing or another. There's going to be rough consensus on what the things mean, and it'll evolve over time. So I think like the best mode is to kind of like treat it as an evolving thing that people are going to keep changing. And so, you know, I think I used to think very strongly that you sort of like needed libp for it to be like properly called IPFS. And yeah, my mind on that was changed by looking at a bunch of other systems that like are just using standard HTTP and other things. I think that's totally fine. I think like, yeah, IPFS over HTTP is something that like maybe feels sacrilegious because part of the origin story for IPFS is as a replacement to HTTP. But today, HTTP is used in a lot more ways, and it's much more embedded as a sediment into the network than it used to be. And so today, if you want to write an API and you want to leverage the tools that people have been writing for the last 20, 30 years, tons of tools that are built on leveraging millions of years of human effort into perfecting them, like you basically need to use HTTP in an API sort of context where you can kind of then start using a bunch of those tools that exist today. And I don't think as a community we should expect to rewrite all of that. In fact, most large-scale IPFS deployments already use a ton of the HTTP-oriented tooling. And so I think it's fine to reason about moving around large graphs over HTTP. I think one of the big problems that existed in the past that has been sort of solved was that the HTTP stack was sort of bottlenecked on TCP. And thankfully now we have Quick and a few other things that have been come in to help solve that. And we have WebSockets and WebRTC and Web Transport and a number of other things, which I think kind of make the situation a lot better. And we've also seen HTTP embedded in tons of other protocols. Like we have HTTP over libp and we have libp over HTTP and so on. So I think today, I think it's much more about reasoning about the distribution of these IPLD graphs and making it making it easy to make things interoperable. I think one of the key things here is like, if you don't have a convergence function somewhere, you're going to end up with tons of tiny little dialect systems that don't talk to each other at all. And I think one of the probably the big differentiating factor in the long term will be that IPFS systems are compatible, like that you can move the data from one to another, and they speak to data portability and sort of splitting the process addressing or from the content addressing. Question around how do I imagine privacy preserving content routing given that there isn't a one size fits all solution? How should we group different approaches to privacy, reader privacy, writer privacy, partial privacy through obfuscation, and so on? What's the number one priority? Yeah, perfect analysis of this. I don't think there's a one size fits all solution at all. And I think this is one of these things that will continue to be a moving target because the underlying cryptographic primitives will evolve. And so almost you're sort of guaranteed that whatever solution you pick today is going to be outdated within 3 to 5 years. So that's kind of like the lifetime that you should expect on any kind of privacy preserving content router that you build today. And I think that kind of evolution will continue for quite a while. I don't think that we'll arrive at like the best way to do it. It's the same thing with routing IP packets. If you look at the network stack and you reason about kind of like what the world does to route IP packets, it does a lot of different things and it's evolved a lot. And so I think like the best thing we can do there is kind of like come up with good interfaces for what a content router is. And here's like where we can lean on a lot of the great work that has been done in the NDN and CCN communities and so on, that have already reasoned a lot about content routing in general, and then create some interface that you can lean on that as an interface that you can then build a bunch of privacy preserving routers underneath. And I think right now, like something that's going to get us there is that now that we have these like large scale network indexers that are indexing, I think millions or tens of millions of records now from large scale content providers, and they're sort of like doing it in a kind of a single node way. That's going to kick off an optimization pressure to build better and better content router systems, plus turn those into privacy preserving tools. And so I think like we'll see a bunch of experiments adding either writer privacy or reader writer privacy together into them. And I think right now it's very much a research question before a research development question. I think there's some work to do to like survey the literature in the last 10, 15 years about all of these possibilities, map that onto the very concrete content routing problem for IPFS systems today, and then suggest a few different directions that we could take. I think right now I'm very partial to systems where a single content router that has large scale storage. So for example, a single content router with say 1 to 5 petabytes of storage capacity in its sort of like local memory, then does some amount of cryptographic work and probably reduces the storage by like, I don't know, a factor of 2 to 10, likely 2, hopefully, but even if you have to pay a factor of 10, it's probably okay. And then can host that many routing records. And I think there's a bunch of different protocols already in the cryptography literature that enable you to do that. Once you have that, then you have a content router that really has no idea what it's routing. And you can just kind of store tons of records in it and then look up tons of records in it. And turns out that petabytes are not that hard to come by now. I think this was very different 10 years ago and way harder 20 years ago. So today, like building a large content router with petabyte scale storage is not actually that hard. And that's going to enable O of 1 routing to almost a vast amount of content on the network. And then you can take those encrypted privacy preserving content routers and replicate them around the world. So you can have large scale replicas of content routers. And I think that's like the most likely thing to work in the long term. So yeah, priority number 1 is just doing the literature survey to identify some good directions, and then after that, and stay tuned for Will Scott's talks on this. He's going to be talking about content routing and so on in the coming weeks. So there'll be a lot of like really cool stuff there. So maybe we can do something like this around IPFS Scam to kind of talk about all of these questions, because I think we basically have a time limit before it'll be way harder to introduce privacy preserving technology into the internet.
Fantastic. Thank you very much, Juan. I don't know if you wanted to take another question, but I preemptively in the chat called at the end of it. Cool.
Thank you.
Thank you so much, everybody, for your time today. This has been a fantastic experiment. I would already preemptively call it a successful experiment. Really appreciate everybody taking time to come out. And that's a wrap. So round of applause for everybody who spoke today. We really appreciate it. Thank you for your time. Thank you for joining us on Friday. And we'll see all of you on the internet.